Welcome, everybody. It's so exciting to see you all here. Grab a chair. There's an empty chair there. There's one at the end of that table. There's one right here. Welcome, everybody. So a couple of things. We sent you all a note. We finally got the website launched. Yay! It's a work in progress, so bear with us. Just send us a note anytime anything doesn't work right for you. Send us a note anytime you see, you think of something that you want that isn't there. We're continuing to add functions, we're continuing to add sections and information to it, but just help us out, and if there's something that you would like to see there that isn't there, please let us know. Everybody should get a copy of, may I borrow this for a second? These are two resources that I wanted to put in everybody's hands. One is called the Urban Water Cycle, and it's a visualization of what happens underneath the ground, how water works underneath the ground. And water down the drain. These are both about stormwater and urban water. They're designed for a younger audience, but I've found that adult audiences who are just learning about stormwater and just learning about how stormwater systems work, these are really, really valuable resources because water goes down the drain and it goes where? Away.
Yeah.
Right? You flush the toilet, it goes away. You know, so we don't think about it, and it's really important to think about. It's sort of the heart of the program. So I wanted to put these into your hands. I would love to hear your thoughts on them, your perspectives on them. So I'm going to start another forum on the website specifically for comments about these CDs, because I'm very interested in your perspective on them and whether you think they would be a useful tool for you to use at any time. Okay? There's a sign-in sheet somewhere going around.
I'm going to send it around.
Okay, so we want everybody to sign in. Any concerns that you want to, yep.
Can you explain how you log in again with our ID and password to get into that special Stewards area of the website?
So when you click on the Stewards, you'll be presented with a login screen where you're going to have to create a profile for yourself. So you're going to use your email address. It's an email address and then a password that you create. Once you hit submit on that, that's going to come to Deirdre and myself, and then we approve your registration. Because I want you to register, I might not want your plumber to register. So we're going to check that the people registering.
You'll be able to identify, see what our email address is,
Yep.
and that way you'll know who we are.
That's correct. Yep. So once we get that email, Deirdre's taking the first couple of days, and I'll take the second couple of days, but we're approving all of those as soon as we get them. So within probably an hour of when you register, you should be able to go back to that site and log in using that login and password.
Okay, so there was no confirmation email back saying because I sent it out and I guess I was waiting for
and then, so
your email went out.
Right. So we launched the website and sent out this email saying, everybody send us an email, and then our server went down.
Oh, I
so we had a look.
So by the end of this class, I'm activating everyone right now. So anyone who has tried to register will be activated. So.
Like I said, it's a work in progress. Other questions or concerns? All right, excellent. Our presenter tonight is Shane Misagi. He's with the University of Minnesota Extension. He's like the stormwater guy. You teach everybody about stormwater. You teach municipal officials and watershed professionals, and you've forgotten more about stormwater than I will ever know. So Shane's been working with us for months and months and months as we have put this program together. So I'm very, very happy that he's here tonight. So I'm going to turn it over to you.
All right. Thank you very much, Vic. Good afternoon.
Hello.
Always well. Give me a second to set this up here, and we should be ready to go. Everybody can sort of see that. All right. Good news is I don't have much text on it. It's mostly graphics and pictures, but just for that. Again, my name is Shane Misagi. I work with for University of Minnesota Extension as a water research educator We'll start with the quick introduction about the program and everything else, and we'll go over some of the things that you folks have talked about last time, and then we'll get into what we're really going to talk about tonight, or this afternoon. Okay, well, to start with our program, again, I work for what we call ourselves the Water Resources team. And our water resources, and this is the website, I really encourage you to check it out. Extension is, not because I work for Extension, but truly for me was a new experience. Extension has a lot of good information on their webs, and you can have access to a lot of good information. So I encourage you to go explore all the different areas, and not just the water. They have a lot of good information online, so you can just check it out. In our team, what we do, we focus, again, as water resources, we focus on maybe 4 or 5 main areas. One is the watershed. We'll talk about what a watershed is and why we care about watershed, what we're promoting this watershed approach. That has been talked about for decades. Nothing new, but it's a greater emphasis we're putting on it lately. Then there's a group of us that used to work on shoreline education. Mainly their focus was what can we do to restore our shorelines, how can we preserve the shorelines we have, preserve that natural habitat and so forth. And then there's a group of us that used to work and still does some work on site sewage treatment, which is basically the septic system. How do we maintain it on the residential basis? What's the best way to construct it and so forth? And then there are 2 or 3 of us that work on the stormwater education, right? The happening topic. And that's what my area is in. I deal with the surface water or stormwater runoff. And then in that our little universe, we have a group or John Bellata mainly that works with what we call NEMO. And NEMO stands for Non-Point Education for Municipal Officials. And you may actually find a lot of interesting programs and information here because it deals with citizen education, elected officials and appointed public officials. And it's really a good way to learn how we can speak to our public officials and what are some of their concerns and how can we communicate with them about the needs and environmental needs and so forth. So that's one program that John leads that, and it's very successful and it's happening all across the state. The other area on the stormwater is what we call the Stormwater Education Program, very unique name. And then in this area, what I generally focus on is working with what we call practitioners or professionals. So we say stormwater education for professionals and communities. In communities, we're really talking about maybe cities, as Peggy mentioned, or a watersheds district, or maybe soil and water conservation district, any entity that has to deal with the runoff. They have to deal with the stormwater, they got to figure out what to do with it. And again, I encourage you to go to our website. Cool videos about soil infiltration, how water infiltrates into the ground, and different things. But the part that we're really happy with is that we have about maybe 10, 12, or more than that, of classes. All of our classes are not videotaped, but all the presentations, the PowerPoints, are available on the web. So if you're interested, for instance, about the lessons learned, looking at in the back 10, 15 years, and saying, well, how is everything working in the stormwater universe? How effective are we? You'll see about 12 to 14 presentations from different cities, from a couple of them from California. We share with you how things are going, or the things we're doing out in the streets, in the field, making an impact, and they're working. So that's our website, and that's what we have. With that, I'll stop talking about our programs. And by the way, ask questions anytime, and if I speak too fast, because I'm so happy and excited to be here, so help me out. If I speak fast, it's because I'm really excited to be here. As Peggy said, we've been talking about this for some time, and I've been looking forward to this experience and meeting you all. So please let me know anytime you have questions, or if I don't pronounce it properly, just let me know. So, let's talk about a review. I know last time you had a speaker, Diane, who introduced the idea of hydrology and the science of hydrology, all the different component parts of hydrology. And if I have it right, there were 4 main objectives that we had talked about last time. One was, understanding how rainfall falls, the movement of the water. You talked about how water moves. Water falls, so how does it move? We talked about how water shapes the land and so forth, and the precipitation pattern. Is that right? All right, good. So everybody knows exactly what you all talked about. That's good. So did you see a diagram like this? All right. So what do we call that diagram? The water cycle, or water cycle. And then we have all the different components in it. It looks crazy, but not really. I mean, obviously you're dealing with water that moves up and down every which direction. And nobody really studies the whole thing, we just focus on one small area at a time. So that way it's a lot more manageable. So we talked about the water cycle. So we have the point that water, I guess the main point for me when I look at this, the main point that grabs me to always want to remember is the fact that water falls from the sky and it wants to go down to the ocean. So it has energy, right? Because it's coming all the way down, it has energy, and it always wants to move downhill. Now, water moving downhill may sound simple, but it's really important to remember that it has energy and it's constantly moving downhill. Okay, then we've talked, you must have talked about how water moves, and of course this is just one of the aspects of how water moves. If this is the surface of the earth and this is the top, of course we're looking at the groundwater. And one thing when I was looking at this slide, what was interesting for me again, the water is constantly moving, but sometimes it moves in days, depending if we're pumping water from a well that's shallow, maybe only 60 feet deep. And what we can recycle that water that falls on the surface of the earth within a days, or maybe we're tapping into water that's really deep, 300-400 deep. And to replenish that water, it may take centuries to replenish that water. So how water moves is really important, and what I'm sure you covered many aspects of it. I like this picture because it leaves nothing to imagination. Water shapes the land, and that we all know that. We know water shapes the land, and how it shapes the land, it shapes how we live. And you can recognize that. This is Minnesota River, Mississippi, and this is St. Croix. Of course, the rivers shape the landscape, and then we end up living where we're near the water. And how we live actually is kind of sort of impacted by how the water shapes the land. Cool? So far? All right. Good. The other part that I think that our fourth objective was precipitation patterns matter. And that's really important. That's one of the coolest things that folks are looking into nowadays, is that with all the talk about change of climates and everything, we're also realizing, looking at the historical data, we realize how much it has rained. It has changed somewhat from year to year. But the rain pattern itself is also changing. So not only the rain pattern is changing, also if you look at the temperatures, now the red being the maximum, and the green being average, and the blue being the minimum air temperature. So if you look at the air temperature, and these are the years from 1948 to 2006, what do we see? When we first look, when we add them all together and look at the averages, we don't see much of a difference. But when we look at the maximum and the minimum, we see a little bit things that speaks a little bit. The maximum temperatures, there seems to be a bit of a trend into how it has happened for the past few decades. So precipitation patterns change and temperature drives that to a degree. So that's important to remember. And the other thing is, it's very local. We're not talking about global thing. We're talking about, if we look at the state of Minnesota, and this plot or graph is showing us precipitation departure. The first time I looked at it, I said, what the heck is a departure, But it's departure meaning how far it is from the normal. If you look at the normal, you're looking at 30 years. Generally, when you talk about normal water level or normal weather, you're looking at 30-year average. So if you look at a 30-year average and look at the Minnesota in year 2011, for instance, here it says that it was less, they got about 16 to 20 inches less water than what would have been normal in that particular year. So we see much of the state was average, but there were a lot of areas of the state that either got more water or less water. So again, precipitation patterns are important. Things are not always steady the same. It changes from year to year. Okay. Got that one covered. Good. That was the easy part. Now we go into the reading assignments. All right, I'm sure everyone has it all typed double space, the summaries and everything. So I think we're talking about looking at a couple of readings, and I thought, well, obviously, I wish there was time that we could sit and talk over all the wonderful articles we've collected, but maybe if you can share one example of each one of those articles you've had a chance to look at it. I think the idea was if, as you go through the paper or CNN or news feed, whatever media you're using, if there was an article about flooding event, did we have a flooding event happen in the past 2 or 3 years, or something that talks about impacted water quality. By impacted water quality, it's a term meaning the water quality was maybe good or bad, and something happened and it got impacted, it went up or down. Or maybe just the article about the rain. So at this moment, we'd like a courageous soul. Yes?
So yesterday, front page of the Star Tribune, forecast leads to flood of criticism. And that was regarding the predictions up on the Red River between North Dakota and Minnesota, and how just days before the peak, they were still predicting several feet higher than they got. So it really led into a good discussion in the article, I thought, about how they do predict floods and how a lot of factors feed in. And in this case, it was the ground that wasn't frozen as it normally would have been that had a major impact, they say now, in their being off.
So because it wasn't frozen, it was absorbing more water.
Right,
In
and
water
therefore, it didn't get as high.
Very good point. We're going to come to that point, I think, later on. So let's get that. Very good point. Thank you. Yes, ma'am.
I read an article that was about the heavy rains grow toxic blooms, and it talked about, this is more in the Lake Erie area, so district or around
The
Ohio.
Great Lakes, yes.
And it was just talking about how much the rain in the spring will determine on how toxic the summer bloom is going to be. And it was the difference between, in 2011, heavy rains flushed 473 tons of phosphorus into Lake Erie. And so they had like a record mat-sized algae bloom that stretched from Toledo to Cleveland. And then in 2012, because there was much less precipitation, if everyone remembers our spring last year, only 69 tons of phosphorus in the lake. And so it was just really a dramatic difference in that area. So they're working with a lot of farm management, and there's some projected projects going on in that area of the country about sort of their planting practices and stuff like that, because a lot of it has to do with their farming practices.
So if I understood it correctly, so when we have rain, more rain, it washes more nutrient or brings more nutrient with it as it washes everything down.
Washing off into the lakes.
So on the dry seasons, if you ask a park manager, how is the lake, or what do you expect your lake? Oh, it's great, it's doing very clear. Nobody can access the lake because the water is down, but the lake is usually good. Very good point.
So I got a question
Yes.
for you then. So in Lake Erie, it's mostly agriculture that has an influence on the water quality of lakes. What about the chain of lakes in Minneapolis that you'll be dealing with? What's the major sources of phosphorus?
Leaves, trees,
Say loud.
trees,
Lawns. Trees, lawns.
yep, yep.
Leaf fall.
Leaf litter, grass clippings, lawn fertilizer. Well, it used to be lawn fertilizer. Supposedly, you use phosphorus and phosphorus lawn fertilizer. But it's the organic material from leaves, and grass clippings are the worst.
And on that, Sarah Hobby
Yes.
is now doing research as to which trees we should use to replace the
Excellent.
dead linden based on how much, when they deteriorate, how they affect what's going in.
And the Freshwater Society has been working with Dr. Hobby and with her colleague, Dr. Larry Baker, to create a protocol so that we can, in the fall, sweep up leaves and then test them for their phosphorus content. So that we can get some sort of indication of, in a 20-pound bag of leaves, how much phosphorus did you keep out of the lake? Because we know how much algae 1 pound of phosphorus grows. We're trying to figure out how much phosphorus is in the leaves that we clean up in the fall.
And is that by species? So you want to know if a 20-pound bag of oak leaves, it has more phosphorus than a 20-pound bag of maple leaves?
What we're doing is looking at the tree canopy and the mix of trees in specific neighborhoods, and we're saying with this kind of mix, this is what you get. We're creating a range. So with this kind of mix, you get this much phosphorus. This kind of mix, you get this. Minneapolis and St. Paul have very, very consistent tree species.
Yeah.
Until they all die off.
So, continue on, Jay.
Yeah, but
Oh,
she was
no,
trying to
thank
figure out
you.
what
Great, you
trees to
said.
replace the dying or dead linden.
You mean
Based on the
ash.
leaf,
Okay.
yeah.
Well, thank you. It is, that's great discussion. Any other articles? Maybe one more? Yes, or two more?
I read one on impacted water quality.
Okay.
They were talking about antibacterial soap getting into lakes and wetlands, maybe lakes. And cosmetics, toothpaste, and how that is affecting the quality of the water.
Talk about urban impact on water. That's
Yeah.
great. Thank you. You had your hands up?
Oh, I can pass since we did 3.
No, go ahead.
Okay.
This is the best one.
Mine, I kind of went a little bit on a tangent with it and focused on drought and talking about a more global perspective and the global land grab that's going on. Just with big banks and billionaires buying up land, and it's not just for the land and control of the land, but the control of the water resources that are underneath, and how they're looking in agricultural resources or agricultural areas, and how local communities are no longer having control of their own water, and they're starting to charge and privatize water resources around the world due to the recognition that there's a profit in that.
Wow.
So,
And where is this happening? Is this in the US and other countries?
yeah,
Or
it's domestic and international.
So,
If you guys have questions about that, IATP.org has an entire article on the global water grab that's going on.
Is there a way on the forum to put links there?
yes.
I think that would be cool. I mean, everybody would have access to the.
Yes.
I'll set up the forum for your article, so you can just post the links.
Yeah.
Great.
Yes, ma'am.
Well, okay, so since you got that, I just gotta bring up this one. There's a great Minnesota Public Radio interview. Well, it wasn't NPR, it was The Story, if you've ever heard The Story. Anyway, it
Oh,
was
yeah.
about how in Iraq, they had drained the huge wetland there that the Euphrates goes into, and how it's, I mean, that's the birth of agriculture, and then now they're trying to fix it again. You can only do so much, but how it's, everybody downstream is being affected and will be for, decades and centuries to come. So I could like just post wherever that is. You should listen. It's an amazing interview.
Yep. I'll put up a forum so you can post these links for each other.
Yeah, thank you for sharing. I guess I love the idea. I wish I could take credit for this idea, but this is Peggy's guidelines telling us to encourage you to look for articles. I think, as I was thinking about it, it's a fantastic way of making us connect that this is a real issue. What we're talking about, when we talk about water quality, it's not just, hey, we'd like to have clean water. We're talking about things that are happening right now and affects our lives right now. It's not a, fantasy, it's a real issue. Okay, so thank you very much. And again, if you didn't get a chance to share with us in the class, it's wonderful that you're going to have an opportunity to put your link on the forum and everybody else can see what the articles you're interested in. Okay. Now let's talk about what we're going to talk about tonight. And I say we because it's going to be hoping that will continue to be discussions between all of us. Well, we did our introduction. 6:20, we're going to talk about big picture. Don't worry about it if we're a little off. I think we have some buffer time in there. We can catch up later on. We'll talk about the big picture. Again, what is the whole deal? We want to get a good grasp on understanding what is the picture, what's the big picture, and then what is the problem. Sometimes maybe something is fascinating to me, but if it ain't a problem, who cares? But is there a problem? Is there urgency? Is there an issue? What's the issue? And if there is a problem, then of course, what's the point of talking about problems if we don't have solutions? So we're going to talk about problems and talk about solutions. And you can see we're giving a good chunk of the solutions, but we're not going to talk nonstop for 60 minutes. There'll be some activities there. And then we'll talk about some of the plan of action. How do we go about taking care of it? How do we implement? Because implementing the solutions is also as important as the solutions. And hopefully we'll have some time at the end to talk, to have some question and answer. Looks good? Mm-hmm. All right. Thank you, because I don't have any other things. This is the only way we're going to be able to do it. So let's talk about to make it easier on my head, you know, I'd like to make chapters. So we have 4 chapters to talk about tonight. Chapter 1 again, we'll talk about the big picture. The big picture is what are the issues facing us. And I think it was fantastic. A lot of articles we talked about, you'll see it's exactly what we are talking about today, is that those are the real issues that is facing us. Some of those issues is the aging ecosystem, or what they call eutrophication. We talked about some Lake Erie that, you know, they're just getting greener. We have these algae blooms, harmful algae blooms, because the system is just getting lots of nutrients. We talked about groundwater. We talked about the issue of increasing demand. We have increasing demand. We're growing. We're having children, which is good. And we're also putting more demand on our resources. And we have a changing climate. As we talked about, within the state of Minnesota, north and south of Minnesota is different. Different averages, different year. The climate is changing. We'll talk, chapter 2, we'll focus on problems again, and what does the stormwater have to do with it, and we'll go through the solutions. So, let's talk about the big picture. I love this, folks at the Woods Laboratory, which is part of the MIT, have put this graphics together, and they give us permission to use it. Maybe you have already seen it too. It's a very cool thing because it gives you a good scale. If you got the globe, and that drop is all of the water that we have on the planet Earth, that's all fits in that little small. So this is our globe, and this is all the water we're dealing with. So we have a finite amount of water, and that's really important. It's not limitless. We have a finite amount of water that we're dealing with. And what's more interesting, if you take that water, more than 97% of it is salt water. You got like 3%, that's what we consider fresh water. And what's out of the 3%, you only have very small amount, which is actually what we call fresh water, or the surface water. We have less than 1% of that in surface water. Most of it is in groundwater or in frozen condition. And I'm not saying this to scare us. We have plenty of water, but we do have finite amount of water. We have plenty of water, and so you're dealing with only, out of that drop, you're dealing with less than 0.5% of that available to us as what we consider fresh water, available fresh water, in form of lakes and springs and streams. So we have to care about this because we have just a limited amount of water, and this water that we have, you know, we have to be careful in managing it. Not only that, we also talked about we have different stressors, okay? We have different pressures on this finite amount of water. We have increased demand, we have eutrophication and climate change. And we'll go over this very quickly. And again, please let me know if I'm just talking fast. But I can slow down at the time. So, let's talk about the demand. Yes, ma'am?
I have a question. If you're including salt water in that, then what does the term fresh refer to? If salt water is part of the finite fresh water.
Oh, I'm sorry. What I was showing, if this is our Earth, and this is, if we took all the water, all the salt and the fresh water together, we'll make this little drop. Out of that drop, 97% of it is salt water. Only 3% is what we call fresh water. Water that doesn't have salt content, you know, it's below 10,000 or just doesn't have any salt.
So that drop represents both fresh and salt?
Yes, all the water. And that's the point we're trying to make, that from that, only 3% is what we call fresh water.
So why is it so small?
Yeah, that doesn't look right to me.
We're talking about the whole mass of the planet, right?
Yes, we're talking about the whole.
Right, but that-
Not the surface water,
Not surface,
but all the way to the core.
the whole volume of the ball.
Right,
Volume, not surface area.
but that little marble there, that can't reflect the volume of all of the oceans and lakes and rivers and streams.
Compared to the volume of the planet.
That's a good point. Maybe we can look into it. I mean, that's a very good point.
It's solid.
Huh?
Underneath the ocean, it's
Right,
solid at some point.
right, but,
You're doing exactly what a scientist is supposed to do. You're supposed to be a skeptic and look into the data. So I think the best that we can do, that is exactly what you're supposed to do. And so the way to do it is we can go to USGS US.gov and look at the, just type in USGS fresh water, and it should take you there. And actually, it would be a very good exercise. Yeah, it is kind of hard to believe that, hey, that's all water we have, and now all of that little, when we already had a little water, and only 3% of that is fresh water, and only less than 1% of that is in the form of available fresh water. But yet we have lots of water. So we have plenty of water. That's not the issue. The issue is that it's limited. It's not endless. And you're correct. This could be different, and sometimes we can look into it. And if we look, either way, it's a limited amount. Are we good with that for now?
Yeah.
Actually, very good. You're supposed to ask questions. So let's go back to the demand. If this is the percent, and these are the years, and you can see Minnesota population compared to 2010, what is guesstimated is that Minnesota population is going to increase 22% by the time we get to 2035. And have anybody here been involved or heard the term the 2040, this initiative that Met Council is doing, going around asking communities to get involved, talk about 2040, where you want to be, and so anyhow, so a lot of things, there's a lot of discussion on how are we going to prepare ourselves for 2040 or 2035 when we're going to have 22% increase in our population. And this is the Minnesota water use demand. Is how much demand we put on water, how fast it is increasing. It's increasing at 35%. So population is 22%, demand is 35% increase.
What explains the difference between those two? I would think, I would expect to find more of a correlation there.
The correlation is that they're both increasing.
They're
One
both
is growing
increasing,
faster than the other one, and that might be, again, this is from USGS as well, and that might be true for the energy, because the greatest consumption is happening in energy, using the water to cool down and everything else.
Yeah.
Yes, sir.
So a little while ago, you mentioned that everybody's having kids, that's a good thing. When you look at this.
I was going to say it's a bad thing.
Well, I caught it right away.
Yeah.
But, and we're looking at population and the two things. I mean, I know it's a taboo, but we never talked about population with all the problems we have. Here, it's pretty simple, if you decrease the population over time, the demands aren't as much. If you can decrease both, it's win-win.
Absolutely.
And I don't have any suggestions on how, it's that we don't even talk about it anymore.
Yeah, I mean, the how is education. It's just, you can have the same graph with education population. A more educated population, the less the rate of increase of that population. But that's very good point. So the demand is there, and that's we know that the more population is putting greater demand on the water. So the demand is real. And we talked about eutrophication or impacted water. Or another term you may hear once in a while is impaired water bodies. How many folks have heard that term? Every once in a while you see on paper or Minnesota Pollution Control Agency puts out a list. They call it the impaired water list and impacted water. Mainly they're talking about if we have a standard, this is our good water quality, we do something to it, we cause the water quality to degrade, then we have impacted our water quality. And this is a map of the US, and looking at the percent of impaired waters, and this is updated 2000, so it's already late for 2010, I think it's going to come up soon. And just showing the percentage of the water in each area, and actually Minnesota is in very good shape, how the number of the impacted water to the total amount of water. And you can see there we have lots of areas that are darker, meaning more than 25% of the available water has been impacted, where the water quality has been degraded. So what is the relation? All I'm saying is that not only we have a finite amount of water, we have put in demand on it, and not all of them are in the best of quality. Yes, sir?
It just strikes me, in looking at that, Montana doesn't have a big population. They don't have a lot of development, but they've got impacted water. Do you have any idea?
They have
Oil wells.
phosphate lines.
I didn't know that.
They also might have less water total, right? So we could have more impaired water bodies because we have more water would show up.
That's true. What do you think about some of the issues we have in Duluth area, northern Minnesota? Is even though there's not much activity, but some of the waters that are impaired because of mercury. We have nothing to do with it, but somebody else in miles away is doing something, and impacts the lakes.
Yeah,
Yes.
well, even the proposed to change the, how sulfide mines or, polymet and the fracking up there is gonna, when they ruin a wetland or whatever it is.
More demands on the limited water, right? So again, none of the things I'm putting out here is, I do not want to come out as alarmist. It's not a hopeless situation. We have valuable resources. We have good, valuable resources that are worth keeping and managing it. That's what we're sitting here. That's where you're concerned, because we have a good thing and we want to keep them good. So it's not, yes, sir?
Eutrophication is generally a natural process also, isn't it?
Absolutely.
Even if there isn't any
Absolutely.
influence from people.
Absolutely. All we're talking about is when we accelerate that process. We're talking about the excess. Absolutely. So we're saying there are a lot of water that are going through this rapid eutrophication, being impacted. And we are so lucky in Minnesota that we have a wonderful group of people who are expert nationally on climate change issues. And Mark Seeley, Professor Mark Seeley, how many of you have used to listen to him on the radio? He's got, it's got one of those voices that you're all tired and listen to him. So it's and he's got wonderful website. I encourage you to check out the website here, or just put Mark Seeley, University of Minnesota Extension, and you'll go to the website. And he's got a lot of good information. And what he's telling us, and it's kind of a general consensus also, is that maybe the volume, how much water per year we get, is not going to change a great deal in the future. Maybe 10+% up and down. So the total amount of water we get per year may not change. But what will change is that when we get that water and how we get it. So if we were used to getting inch of rain now, another inch 3 weeks later, half an inch. But this may change into getting 2 inches now, and not much for a few weeks, and then another inch. So the pattern is changing. So when he talks about amplified precipitation signals, he's talking about that we used to get just maybe this gentle rains, and now we're going to get this big rains, which translates to what?
Floods.
Floods. Right. So now all of a sudden we're impacting flood runoff. Okay. So
I
that's.
just want to remind everybody that we'll put the PowerPoint on the website so you can have all of these links.
Yeah. So again, to go there. So anyway, so the point we're going to make is that, not to take too much time, is that we have fresh water, we have limited fresh water that are facing 3 demands. They're facing 3 stresses or 3 challenges. Okay, and we care about it. And the reason we care about it, again, those are the reasons we care about it, and we want clean water. In order to have clean water, we want to protect and manage it. And that's really the big picture. And that's all I was trying to communicate is the big picture. And hopefully that worked. And to test that, we're going to have a little test to see if that worked. You don't need to put it here, but I've got this printed here just for you to write down. Or if you have your own sheet or own books, you have it. Everyone has their own journal. Oh, then skip this and keep it in the journal. So what I'd like you to do, maybe take 5-10 minutes. This is an individual assignment. Let's take 5 minutes or so, and in your own words, based on the articles you heard, based on the articles you have read, and what we've talked about so far, you tell me what are the issues facing our finest fresh water resources. 2 or 3 minutes actually. Whatever you want. Yes, ma'am.
No.
Pretty much in sync. Yeah. Anything new, exciting? Okay. All right. So, well, you guys are very cooperative groups. You agree with whatever is good. So now you agree with the big picture. So that's really the picture, because that's really the driving force, right? Because we want to know what's the big picture, kind of to put it together. So let's talk about the next thing. So Whew, good news is we finished one chapter, so we're chapter 2, we're going to talk about the problem. What is the problem then? If that's the picture we have, but what's the problem? What does stormwater have to do with it? Because that's the topic for tonight. Well, how does stormwater come into play? And what we want to talk about is that, I am sorry about the text here, but I just read it to you, is that both the natural drainage systems and constructed ones are susceptible to excessive stormwater. So what we're saying the problem is this, that both the natural drainage and the system that we've constructed for the past 30 years, we won't even judge it if it's good or bad. Both of them are susceptible to the excessive runoff that we're dealing with.
What do you mean by susceptible to it?
Into damage, there will be damage. So they're not able to handle that runoff. Thank you. It's good. So that seems to be the problem. Let's see if that is really the case. All right, so we're talking about the water cycle. But, as I said, it's a big topic. Folks spend a lifetime studying this cycle. But what we're talking about tonight is just this part. We're talking about surface runoff. What we're talking about is, the area we want to focus on is from the time the water falls from the sky, hits the ground, and from the ground, once it hits the surface, it has to go somewhere. That runoff that's generated, that's the area we're dealing with. And actually this thing, and the first thing to do with it, and I know last time we also talked about, is measurement. We need to measure things. Before we can even figure out what's happening with this runoff, we have to measure and understand, well, what happens on the streams, what happens on the creeks. So this is the area of our focus. And to start with things off, we have to measure things. And the way we measure this is that, if you can imagine this is a creek here, or the river, we put a little well next to it, and we put a couple of pipes that takes the water into that well, and we generally just read the depth or the height of the water into the well. And then since we know the dimension of this area, we can figure this out, have a depth and a length, and we can figure out the volume of the water or the flow of the water based on that. And then we translate that into what we call a flow. So how much water, either cubic feet per second or cubic meter per second, whatever unit you want to choose, then based on that calculation, we can figure out how much water is moving. And I'm just hitting this right up front because everything we talk about has to do with measurement. We're going to say too much water, too little water. This is one of the ways to measure the water. And we talked about, so that's how we measure the water. And so what we're talking about is if it rains, we're going to get water in our stream. And that's how we measure it. And this is another way of me trying to show you how it actually happens. So if I'm standing in the stream and it starts raining, there's a bit of a lag, and as it rains more, if I'm standing in the stream and I'm measuring in that well how much water I have, the more it rains, the more the water is going to come up in that stream. But it's going to top off at a level, and then gently it's going to fall off. This is what we call a hydrograph. So this is time, and this is how much water I have in the stream. This is my natural hydrograph. It looks like this. Or it could look like this. Everything is different. But if you get a typical creek, natural creek, this is how our hydrograph is going to look like. So the water gently comes up and gently drops off. But it all depends on a lot of... Yes, I'm sorry.
Could you give like a clear definition of a hydrograph?
You bet. My clear definition is going to be very muddy, though. But if I'm hydrograph, basically I'm looking at the flow of the stream per time. How much water I get through time. So if I go into...
That would be a rain stream, basically, or a rain two stream.
As it starts raining, if I'm standing in the stream with a gauge or a staff or a ruler, and I'm looking at how much water depth I'm getting, if I'm reading it, if I put a ruler here and I read the water, oh, my units are gone. That's why it's not making us. Good point. That's for the rain. There should be a flow. I'm sorry, I don't know why it doesn't show. There should be a measure of how much water I have here. So if I'm standing in the stream, and it rains for half an hour, the water should come up maybe 3 or 4 inches. And if I get about an inch of rain, then I get more water in the stream. And as the rain stops, then obviously the water is going to stop in the creek. Did I answer your question?
A hydrograph is a picture of how much water is flowing over time.
Thank you. That works. Yes.
And then I don't want to muddle this further, but in order to have a hydrograph, do you have to have the hyetograph as well? Is that a requirement? The one that just shows the rainfall amounts
At the
over
top,
time.
you've got a different.
Oh,
graph.
no, that's just to show, I see.
To combine two graphs on
Right,
one.
that's just
Okay.
combining two graphs in one.
Sounds
Okay.
good. It looks good.
Just,
cool.
it was supposed to make it
It-
easier to see
No.
it, but it didn't.
Well,
do
it,
that.
what it does illustrate is the lag, yeah,
Yeah.
that's cool.
And that's the point. And so what we basically say, if you're in this natural area, this is what happens. Now, we already talked about one of the issues in the Red River was that idea that the ground wasn't frozen. So the conditions, there are many conditions that change how that graph looks like. And there could be meteorological factors, or weather, or it could be physical character, like the land use. If it's a forest, that hydrograph is going to be a little different if it's a city. You know, if that water generated off of a city block, that water, how fast the water gets to the pipe and how much water we see in the pipe is going to be behave a little differently. How much rain we have per hour, intensity, all that is going to make that graph move back and forth. But for right now, we're just going to focus on what we call a natural versus an urban area or impacted area. So if we look at the typical annual water budget in an area that what we call natural, a typical natural area. And we compare it with what we call an impacted area, which is, what are some of the differences you see here, by the way, when I say impacted? What are some of the main differences you see in those two pictures?
Fewer trees on the right.
Right, some trees are gone because I gotta have a hospital, I gotta have a police station, I gotta have a school, community center, so I gotta go cut down trees to develop roads to get to those places, so I'm gonna put more asphalt, you gotta put more impervious area, and so forth, so it interrupts that water cycle. So the main things we're going to see here is that in a natural area, when I get rain, I get about a third of water goes in, finds its way into the ground, infiltrates into the ground. I get a third of water that evaporates, that goes back into the sky, and I get generally, I mean the numbers are all, you know, for suggestion. I get about maybe 1 or 2% what is considered runoff, that the water just runs off the surface and finds its way into the creek or the lake. But when we impact the water, impact our landscape, what have we done? We don't have as many trees, so we minimize the evaporation into the sky. So we're going to have less evaporation. We have more of a hard cover, so there's less area for water to infiltrate into the ground. So rather than getting more than 30%, now we have less, something like 15% only going into the ground. Yes, ma'am?
We had a similar chart like that last time, but the numbers were a little different, and one difference is this interflow. That's something that wasn't on the chart last time. What is that?
This one here?
Yeah.
It's what we call shallow aquifer or
Base flow?
base. That's what feeds into the base flow. It's the water that before it, you know, it's good. We'll just go for it.
What's the number on it?
Here again, the numbers here is like 25% or something like that. But what the idea is that also gives, what the point I was going to make is that the amount that you end up as runoff here is about maybe 1 or 2%, but end up here it goes as much as 30%. So what you're doing, so the takeaway message is this: I am not creating more water. I still have the same amount of water. All I do is I divert more water from other parts of the water cycle into the runoff. Yes?
So with this graph here, instead of an urbanized land or pretty much like constructions of big businesses, corporations, make malls, things of that caliber, when it comes to the water flow between the natural and the urban, is that different of how natural cabin setups are constructed? Does that affect water also, in your opinion?
Absolutely. I mean, it depends how sensitive your area is. You know, you might have more impact if you're next to a trout stream, and maybe you put 5 cabins, you may have more damage than if you are next to a lake that's more resilient, and you can put maybe a couple of Kmart's next to it. But you're right, it all depends.
Which I would like to refrain from doing. I mean, the reason why I brought this up is because, I mean, for the idea, because I'm kind of telling myself here, I want to construct a village, and I'm wondering if I have something that is non-constructive, urbanized, to actually.
That is excellent, and we're going to get to it, because what you're talking about, that's exactly part of the solution. Okay, how do we do it? No, that's a very good point. Okay. You're going exactly where we want to go. How do we do that? How do we do it without creating this scenario? And we're going to get to it. Okay. Okay, very good point. So the message here in this graph is that when we impact the landscape, we generate more runoff because we interrupted that water cycle. So what does that do to this graph that we were showing before, to the hydrograph? That's what we're going to show is, so here on a natural scale, this is what our hydrograph is. It rains, and if I'm sending in the stream, the water comes up gently, drops up gently. But here, can you guess what would happen? Here, I only got 1 or 2% as runoff, but over here, after I block water finding its way into the ground, can't evaporate, so we'll end up more with surface water. So we got like 30% runoff. What's going to happen to this plot here? You're right. It's going to shoot up. It's going to shoot up. So I'm sending the stream. I get a flush of water, gush of water, comes up, and it drops very quickly. And it's this excessive water, this bulk of water that causes the problem. This is the culprit. This is the amount of water. When we talk about excessive runoff, we're talking about this water, this bunch of water that we got all of a sudden much faster than before. And now we don't know what to do with it. That's what this excessive runoff we're talking about. And this bulk of water or amount of water, this is what we end up with. It drops off too fast, so we have too much water, and it moves too fast because it goes down too fast, it moves too fast, and it also, we have more water washing down more surface, so it brings with it more nutrient, causes more erosion. We'll cover all that, don't worry. So again, this is some pictures to remind us how these things work. So again, the problem is when we end up with this excessive runoff, what it does, it moves down too fast, water moves downhill, it has energy, we have lots of water, the streams were not made for that excessive amount. The streams cannot handle it. I'm sure Diane, who does lots of streams, she must have talked about this. So we end up with erosion. So as we erode the soils, what do? We carry the soils with it, right? The sediment with it goes down to the lake, carries nutrients with it. We just accelerated the eutrophication process. So we get three main problems. This bulk of water, this excess amount of water creates three problems. We end up, one is quantity. We have too much water, right? We didn't create any more water, but we have too much water in the form of runoff. Then the second problem is the rate. It's moving too fast because there's lots of water, gotta go a place, it moves too fast. And as it moves down, it washes down everything with it, causes erosion, so it's quality as well. So those are the three main problems, right? And somebody may come up with fourth, down to two, but for most people you'll hear they say three main problems. These are the three main problems that we must know. These are the things that we've got to deal with. So when we talk about managing stormwater, those are the three things we want to manage. All right. Did we just find out about this today? Not really. This is the Federal Water Pollution Control Act. And at that time, it was 1970s, and the goal was that all the navigable waters will be, all of the pollutants will be eliminated from navigable waters by 1985. So the point is not to point out that we didn't do it, but the point I want to make, it's a problem we've known about it for a long time. Actually, the U.S. has been leading the effort a lot sooner than lots of other places, particularly Minnesota too.
But you do realize it's America, right?
Yes, but things takes time, we've known about this problem for a long time. And the question you asked about the village, people started asking the question, why didn't we have this problem before when we were doing the villages? Well, so one reason we didn't have as many people. The other thing, people started saying, well, maybe the way to build these villages or to build the cities, the way to do it was they started noticing if you mimic the natural hydrology, things don't go as crazy. So they say, you know what we have to do, we have to mimic and restore the natural hydrology. When we talk about natural hydrology, what are we talking about? Remember the graph? We had that little gentle graph, and then we had the rapid graph. So they're saying, as long as we can mimic that natural gentle hydrograph, then we're okay. And they called it green infrastructure. So you've heard, how many of you have heard the term green infrastructure before? That's what we're talking about. Green infrastructure is to manage wet weather. By the way, this is EPA website, great website, go to it. Managing wet weather or rain, we need to mimic natural hydrology. So I said, oh, that's great. This has been in the books for 30 years. In Minnesota, we got serious. We said, you know what? Not only that's a green infrastructure, but in Minnesota, we're going to make it a law. In Minnesota, since 2009, we have said, folks, we're going to incorporate low-impact development, an approach of developing the village. That's exactly the goal. I want to make my city in a way that I have minimal impact on the environment. And then to do that, it is a law in Minnesota that I need to mimic the site's natural hydrology. Yes?
It's interesting that there's a state law like that, and in a lot of cities, there aren't hardscape rules in terms of your percentage of hardscape on your property can range from 0 to 100%. In the city of St. Paul, I'm dealing with this right now, there is no restriction on how much hardscape you can put in your property. You could pave your whole yard. Hardscaping, patios, walkways, gazebos, decks,
Sidewalks,
anything, sidewalks.
Thank you for defining it. Thank you.
That run. So there's an inconsistency between
Absolutely.
the state and city jurisdictions, and perhaps even at lower levels of city government.
Hopefully folks like you who are coming here will change that. Yes, ma'am?
Do you know if that refers to new development or redevelopment of a space?
Very good point.
Is that
Very
even a
good
law
point. It's
or a suggestion? I mean,
This is a suggestion. This is
okay, what
this
does
is
the
the
statute
concept.
say?
The green infrastructure is the concept of mimicking natural hydrology.
Right, that's a concept.
In
What does the law
Minnesota, the low impact development is the law. When we do development, we need to use an approach where we can mimic the natural hydrology.
Yeah, but
This-
when does that take it, when
yeah,
does
and-
it take effect? That's
And are we, does that law mandate low-impact development?
Yes.
That's a fine definition.
Yes.
New development
For new
All
developments.
new development
How is it
must meet that standard, is that right?
Does that mean new development in current
And each
residential
city
areas?
has different statutes on how that works.
Exactly.
In the city of Minneapolis, if you look at your water bill, I believe there's a fee for getting taxed on how much impervious.
How much runoff you're generating off of your parcel, you're correct. And if you do green infrastructure, some cities, they say, you know what, we're going to reduce that fee,
Yeah, but it's
Oh, yeah,
pretty, it's pretty hard to get that. I mean,
unfortunately.
you almost have to go to.
Very
some
good
hardscape
discussions.
To qualify for it.
Yeah, very good discussion. And the excellent point about the development versus redevelopment, because Pei mentioned, depending on, I'm mumbling because depending, if I used to work for a city, each city, within a city you have different organizations, watersheds, or different areas, and you may have different definition of what is a development, and at what point, how much you can remodel before that's considered redevelopment, that would have to follow certain things. It is working out. Actually, we're part of a group that's putting some standards of what is a low development, a low impact development. So it's happening. It's happening. Maybe not all this problem discussed. Okay, so let's go back to this. So we're going to be on time. We're going to be here until 10:30, right? Okay. So, but low impact development. So, okay, what's the message? Green infrastructure. Since 80s, we understood one thing. If you want to build a village with minimal impact, we have to restore and mimic natural hydrology. In Minnesota, we said, wait a minute, we're doing everything, and it seems the only way to beat this, the only way to do it with the glob of water that we've got on our hand, is to mimic natural hydrology. So, what do we need to know before we can do anything?
What is the natural hydrology?
Excellent. I never paid her. She was.
I'll collect
So,
it.
The drainage system, well, what the heck is a natural hydrology? Because if I'm an engineer and you tell me, you know what, build the village but mimic natural hydrology, well, I gotta know what's a natural hydrology. So, or a drainage system. If you talk to most, everybody knows drainage. All farmers do drainage. Everybody does drainage. That's the question we're asking. What's in a natural drainage system? This is an aerial photo from Brainerd area. Aren't we lucky? All that water, all the wetlands, all the stream. When we look at this, what do we see? Well, I hope you can see some of it from back there. Generally, what we do see is that different components. First of all, we have a landscape, right? The whole area. We have trees, we have land, we have forests. That's part of the landscape. That's part of the drainage system or our natural drainage systems. Then we have low spots. You probably won't see it on the back, but we've got these low spots that we call, what do we call them? Slough or wetlands or swamps. Whatever we call them, they're the low spots. They're all the little spots, the holes in the ground that can hold a little bit of water. So that's part of the natural drainage area. Then we have conduits, or things that connects all the low spots together. So we have our landscape, we have forests, we have rocks, we have soils, and we have these low spots that hold the water here and there. Then we have conduits that connects all of them together. We call them what? Streams, rivers, creeks, and so forth. And then all those conduits bring them together, hold them in one big spot, and we call them lakes or storage. So in natural hydrology, it's got landscape with lots of trees, we've got low spots, lots of places to hold the water. It's not all flat. And we have conduits that connects this together, and we have a storage area. Bingo, we have our stormwater management plan right there. So that's what we want to copy, so that's what we want to do. So that's what we're going to talk about. Well, how do we do that? Well, we've learned to mimic the same thing. So when we talk about a constructed, running that bulldozer was so much fun, we had to make everything nice and flat. But now we're going back and we're putting all those little basins back in there to hold the water here and there. Then we talk about, how many of you talked about stream restoration? Hot topic nowadays. What are we doing? We're bringing some of those conduits back, some of those natural conduits back into the system. Rather than having the pipes that transfer everything so quickly, we're putting some of those creeks back. And of course we have ponds, which are the same thing as storage. So this is kind of a parallel of the constructed versus drainage system. Doesn't seem that complicated, does it? All we have to do is design like nature, so it's good. So we know what's in the natural drainage, but we got a couple of things. Just really important we got to remember as we design this thing. One of the things we have to remember is that we need to design for a changing climate. What worked for us 30 years ago, what we consider natural, what we consider a native plant to here, we have to ask ourselves. I'm not saying it's going to be different. We have to ask the question, will it be the same? Because what I put in the ground as a public works director, somebody who is responsible for your tax dollars for the next 50 years, 80 years, what they put in the ground has to last that long. Is there going to be the same pattern for the next 60, 80 years? Am I going to design something that worked 80 years ago, or am I going to design something that's going to work for the next 80 years, or 30 years? So designing for a changing climate. And then the next thing is, we need to have a watershed approach. And by watershed approach, it's a very simple question. We need to ask ourselves, where does that water come from, and where does it go after it leaves my site? So, we're going to design like nature, but we're going to remember two things. We need to design for a changing climate, and we need to ask the question, well, where did that water come from, and where is it going to go after it leaves my site? And where do I get all these wonderful ideas? Again, in Minnesota, we're lucky. There's a manual called Minnesota Stormwater Manual. And again, all the slides will be up and all the links are up there. All you gotta do is type it in Google and take you to this wonderful manual with lots of information. So are we good here? So the takeaways. Chapter 1, we talked about the big picture. Chapter 2, we talked about the problem. The main three problems are what? With the excessive water, that global water, that's the scientific water.
Rate, and quality.
Those are the three main problems that we have to deal with it. And to solve that problem, we have to do what? The green infrastructure. What's the concept? Mimic nature. But in order to mimic nature, we know the drainage system. We know the component of the drainage system. But we got to keep two things in mind, right? The changing climate and watershed approach.
So I have a
These are
question.
Good. So let's see. Let's take another.
Wait, before
Yes.
we go, I have a question. If we mimic natural design to solve a problem that is inherently supernatural, is that going to be adequate?
You guys
I
are
mean-
good. Absolutely. It's a
What do you
very
mean by
challenging-
supernatural?
By supernatural, I mean we're building buildings, providing infrastructure for people to live. That's outside of what we think of as the natural environment.
Everything has a cost. That's what
Yes.
this is. Absolutely. And we'll talk about that. And fortunately, we have lots of solutions that we can do okay for now. So, but that's a very good question. Okay, so let's take, good news is bad news I'm late. But good news is we're going to take a few minutes to do this exercise, then we can take a 5-minute break, which will also freshen up. So let's get into the groups of 2 or 3, and then in your journals again, maybe you can help me out identify, I'm sure you can do that in 2 or 3 minutes, identify the 3 main problems that are caused by excessive stormwater runoff. What are those 3 problems, and what should we be mindful as we develop the strategies to deal with this problem? Is that clear? Is that good? All right. Let's take a couple minutes, and after that you can take 5 minutes break, or now take 5 minutes break. You agreed that we have issues, we're dealing with 3 main issues and so forth, and now we're going to jump into solutions. So this is the whole thing. So we took an hour and a half to talk about what we can do about it, because things are good. I mean, we're able to handle it. We can manage this, right? If we put a person on the moon, we did that, 40 years ago? So if we can do that, we can deal with runoff, I think. That's so it's a good thing. Anybody, maybe just, I know you've heard it, we've repeated this a number of times, but anybody would like to tell us what they had? Go ahead, please.
I had artificial structures as far as rainscapes that just build up water that is not being drained. Another thing was deforestation, which disrupts the climate cycle, and then contaminated aquifers of contaminated water being drained, and for those that pump out of aquifers, the water underneath could be contaminated.
You're absolutely right. Those are all issues. Now, specifically, the 3 main problems that we were talking about on the couple of slides. I mean, they're all kind of related to with that glob of water. Then we have this graph, that, the normal stream or natural streams, and we have the rapid streams. That glob of water, that's a scientific term, glob of water. What are the 3 main problems that creates for us?
Excess runoff.
Excess runoff creates 3 main problems. What are those 3 main problems? Because the reason we want to...
Volume, speed, and pollution.
Right, because the reason it's important, anytime we have solutions, our solutions has to match the what? Problems, and those are the 3 problems. So anytime we have a solution, we're going to say, does it do any of those 3? If it doesn't, then it doesn't belong here. It could be something nice, but if it doesn't do those 3 things, then it's not the solution for stormwater. So those 3 problems are, again,
Quantity, rate.
Yes, it's quantity, rate, and quality, and erosion is created. Okay, good, we got that? All right. And what should we be mindful as we develop those solutions? 2 things we got to be mindful of.
Climate change and where the water comes and where it goes.
Yeah, we got to ask ourselves the question, well, where's that water coming from? And where is it going to go after it leaves my site? That is really important. We'll get to it. These are the drivers, the concepts. Okay. Another good news. We got 2 chapters. We got 2 left, but it will go quickly. Trust me. So now we're going to talk about solutions. We've been talking a lot about the problems. Now we're going to talk about solutions. We're second nature. We know how to make the solutions. All we got to do, mimic nature. Boom, easy. So we talked about this again. The hydrograph, we have this natural one and impacted one. All we got to do, bring it down here, right? and minimize that. That's all we gotta do. Just think about it. You gotta squeeze that water down. That's all. This is what we're gonna do. And we actually do that. And we do it with what we call BMPs. How many of you have heard the term BMPs? Best management practices.
Oh.
And don't worry, that term is changing already. In the new EPA, they're using, I forgot, management strategies. Do you remember what they?
Stormwater management strategies.
Strategy, yeah. It's that term is changing. But for now, we'll just go with best management practices. So, best management practices are these tools that we use to squeeze that down. And if you had a very excellent question, and you see I stopped it here. Because in reality, we'll never get to what it used to be. We have to accept that fact. We have to understand when we build something, we will change something. But we've got ways to compensate for it. So that's all we can do. Okay. In my opinion. I mean, you can all right, so what are these tools? This is what we're going to talk about. These are our solutions. So we have tools or best management practices that we can bring that graph down to. And we're going to talk about, we're going to spend the next 30, 40 minutes talking about BMPs, best management practices. What are best management practices? Oh, there are good ideas. No, they are proven ideas. It's really important to understand that. It's not that I have an idea, I think we should do it. When we refer to best management practices, stormwater best management practices, we're talking about things that are proven. It's the law, and there's a definition for it. I know I've broken all the PowerPoint rules by too much text, but the idea was to show you it is actually defined. It is defined as means, practices, techniques, measures that prevent or reduce water pollution from non-point source and The point is, it has to be a proven, engineered design. These are best management practices, not simply just random ideas. We have a whole series of it. We can refer, that's what we're referring to. So these are the things that we know work. Okay. When you're talking about best management practices, we love to categorize things, right? Everything has to go to a certain bin. So we can say there's some structural best management practices, or BMPs. Everybody okay if I just say BMP? Mm-hmm. So we have structural BMPs, meaning we have to have materials to put it together to create the BMP, or we can just have a practice that doesn't require materials. For instance, if I go out and clean the street, I've just cleaned the street maybe with the material, but I really didn't have to construct something. So that becomes a non-structural practice. Or if you teach me about, hey, don't put your paint into the water, and I say, oh, okay, so I'm preventing the pollution. I didn't have to construct anything. It's a non-structural BMP. Or maybe I can use a BMP that only lasts a couple of days, so it becomes a temporary BMP, or a best management practice that may last 40, 50, 80 years, and that becomes a permanent BMPs. Okay? The only reason I shared this with you, so if you hear the term here and there, you say, oh, well, I know what, It's just really the way we are fascinated by classifying everything. The way I feel is really neat way to classify best management practices is through this chart, which comes straight from Stormwater Manual. And the way to do it is you look at the features, function, and benefits. Because all those relate directly to what? To the three problems we have. It has to solve one of those three problems, else it's not a solution, right? So anytime we talk, and then we put them in this category, we say, okay, first we're going to prevent the pollution. We're going to prevent it from happening. That's our one category. Then we say, you know what, we prevented it from happening, but we ended up with the rain on our site, so let's deal with it right on site. So we're going to take care of it right there. Any of you folks have heard that term? I like that term. They use that stop the rain where it falls. Mm-hmm. It's really that simple. And I think that half of our problem is the solutions are so simple. People expect this high-tech solutions. It's not. Stop the rain where it falls. That's really when we talk about source control. Okay, so I prevented it. I controlled whatever falls right there, but I still end up with some that is going to run off. It's going to leave my site. But before it leaves my site, there are state rules that say you cannot let it go downstream unless you treat that water. And by treat, By treatment here, we mean is that we have to bring that water quality to a certain standard or back to that natural background of quality. So, and that's what we call on-site water treatment before it can go downstream. Whenever we follow this hierarchy, whenever we go through preventing pollution, treating it on site, and then treating it before it leaves our site, we call this a runoff management treatment train. Don't ask me about the terms, so I'm just using somebody else. So the treatment train is basically it. You know, as you can look at the arrow, it gets thinner and thinner. So I have lots of water, I go through all the stages, and I end up with less and less water. The goal is to do what? Remember that hydrograph, it was up here, and we wanted to do what with hydrograph? Thank you, I was getting worried there. We want to bring it down, right? So the whole idea is every stage we want to bring it down. Okay, so the next 20 minutes or so, I'm just going to run through lots of BMPs. Stop me if you have any questions. Let's start with pollution prevention. These are our tools. These are the things that are going to help me to minimize, to address one of those three problems. Quality, public education. It works. It really works. It makes a difference. If we can educate the public that the animal waste ends up in our creeks and it causes pollution, causes viruses, bacteria, and so on, and nutrients, if we eliminate that, then we don't have a problem. The public education, we can focus on animal waste. Or we can tell folks, you want to fertilize your lawn, more power to you. Don't put it on your driveway. Don't put too much on it. Manage it. Control it. Or use something that doesn't have phosphorus. Minimize the impact. That's public education. It's going to have an absolute impact. What about trees? We talked about trees and articles in the trees. We're doing studies with the leaves and so forth. So why not do that? Why not help the homeowners, as many cities do? Anybody here has an adopted broom? Cities offer brooms to homeowners, so you can sweep your streets. You can keep the catch basins all clean, so it doesn't plug in the spring, and you keep everything, all the debris off of it. So many cities are doing that. Keep our streets clean. Hey, that's going to prevent it. Am I constructing anything? No. It's a non-structural best management practices, but it's very effective. What about on a large scale? We do street sweeping. You've seen these machines, haven't you?
Today?
All right. So they're going around sweeping the street, and they do it right in the spring before the big rain, because all that material has been sitting there the whole winter. Let's get it out before it goes into our creek, before the pollution goes downstream. So pollution prevention. Yes, ma'am?
Real quick story, the year of the big Halloween storm, that snow fell 2 days before the streets were supposed to be swept. The next year, they tested the phosphorus levels in Lake area. They had doubled over the previous year.
Because it laid over all the leaves.
Because the snow laid over all the leaves, it all went into the lake, and the phosphorus levels.
Was that when they started saying that you couldn't rake your leaves into the street?
No, it was before that. Before that law came after that event.
Things going okay? You guys can let me know. Let me know. Slow down. Speed up. If you're bored, let me know.
Anyway, I didn't mean to interrupt, but if you think it does, it makes an enormous difference to get the leaves out of it.
Absolutely. And that's the whole point, is that this is, when we talk about best management practice, we're not talking about random ideas. Because folks, remember that Clean Water Act that we showed? This is not a new problem, is it? We've known about this for decades. So these are proven techniques that we know that work. Okay, public involvement. Nothing is going to get done unless we have advocates out there. You sitting here as part of the public involvement, you get in the process going. Sharing with people, letting folks know that their behavior has a direct impact on the water quality. It makes a big difference. Illicit discharge detection and elimination, IDDE. Why did I put that here? What does it mean? Well, a lot of us are not aware that if this is the catch basin on the street, this is our street, this is the catch basin. A lot of us are not aware what we put down there doesn't go anywhere except to our creeks and lakes. And a lot of businesses, we found it handy to put a pipe in it and let the business go on. No one ever said anything. It's been happening for 30 years. But we can go out there during the hot summer days when it hasn't rained for 2 or 3 days, and if we see a flow in these pipes, what does that tell us? Well, it hasn't rained, right? So we know something's going on. So many cities are getting involved with, many folks are doing this, you know, on the weekend or so, taking a walk, they're checking it out. I'm not telling you guys do that. It's dangerous, don't do that. But many cities are doing their own. They're doing this illicit discharge because it's part of pollution prevention. If you can prevent it from going downstream, you solve the problem. So that becomes a very important issue.
What about car washes? The kids are putting on car washes in the church parking lot, or, hello?
It's flowing into the sewage drains.
Yeah.
Hopefully they have a system to handle that. Yes. Maybe they can wash it on the grassy area.
Sometimes I've noticed even just in the Minneapolis neighborhood, people drain their pools or whatever. They'll just put a big pipe or a big, you know, hose, and it just is running down the street from, I mean.
Yep. It has actually, if you go to the MPCA site and type pool standards, there's a specific standard amount of chloride that it cannot have. It has to be below a certain level before they can put it downstream, because it does hurt the algae and bacteria and everything.
Or just a high level of chlorine that's going to be running into the creek.
Yeah. So they cannot do it. So that's the illicit discharge. The other idea is the better site design. Okay, I know as a homeowner, we don't really design things, but we do purchase things. So if we have an open mind about the better site design, if we know if they're going to if the city proposes to redo the streets and they're saying, you know, hey, we have 2 or 3 rain gardens that can put on your right of way so you can take care of it. We'll talk about what a rain garden and so forth later on. But if we're open to the ideas of integrating the stormwater management into our streets, if we accept that, I think the cities will go along with that too. So really to accept the new ideas, then, you know, in the cities, it doesn't have to look exactly what it did 30 years ago, it could be a little different. We can have bikes and we can trees and so forth. Yes, ma'am?
So does low impact development refer to streets as well?
Absolutely. A lot of the streets of construction, this street particularly has a lot more design underneath. If you go to the website, you see underneath they have underground storage areas. The trees are calculated of how much rain they can hold before the rain can reach the ground. So that is calculated. All these areas here are receiving water directly from the streets. So actually, very minimal amount of water runoff from the street goes downstream. So that's an important. But we need to be open to the idea. We need to accept that we're not going to drive 60 miles down the road. So that's the idea. Salt storage is an important area. In wintertime, we all love driving and we love to drive 60 miles even we have 3 inches of ice. Nobody wants to slow down, so the cities have to put salt down. It's easy to blame the folks who put the salt down, but we also need to learn to live with no salt and slow down. So again, the homeowners, we don't do it, but if we can accept the fact that, and we also use salt on our sidewalk, on our driveways. Again, the salt has impacts the water quality downstream. So these are all some of the example-driven pollution prevention. By no means is all of it, but examples, quick example. Did you have a question?
Oh, no, I was just thinking about the salt thing. I mean, I know that they teach commercial businesses, best practices as far as like when to put salt down and, it's just so it doesn't end up.
Absolutely.
The excess.
We'll actually be setting up a workshop for you this winter in chloride management.
All right.
Oh.
Good. So it is a, oh, I'm sorry. So that's supposed to, the next set of best management practices are site control. And what do we mean by site control? Source control. Source control. When it falls on the site, we want to take care of it right there. We want to grab as much water as we can, as much of the runoff before it goes downstream. So every example that I give you, that water has to do something, right? It has to slow down. So prevention, we didn't generate it. So we reduced the volume in a sense. It was just everything. It solved all 3 problems. Source control, we're going to hold on to the water. What is that going to do for us? It's going to reduce the volume, right? So we're not going to generate as much runoff. Pervious pavements. These are the areas, if we're going to have a driveway, if we're going to have a deck or whatever the space, maybe we can use materials that allow the water to go downstream. It goes into the ground, not downstream. It allows the water to infiltrate into the ground. Okay? Or maybe, if we want to have grass, if we have a church that we have only 2,000 cars coming in twice a week, but we need a huge parking area, maybe we can in Minnesota may not be practical in all areas because of snow, but in some areas it might be available if you can plow maybe 2 inches off the grass. You can still keep the grass. You can have a grassy area where the water can infiltrate into the ground. So you're minimizing the runoff again. Now, of course, if you have this area here, after a few seasons, you're going to have things growing in it because things get trapped. So you need to have maintenance, and these things need to get washed, high pressure wash and so forth. Wash it once in a while to get the stuff, all the junk out of it, and again regenerate the whole system. Or you can, again, we talked about grass. You can also have grass that actually can handle lots of weight. Now we have this what they call the turfs or reinforced turf. Actually, all of this is a plastic mesh you put into the ground, into the soil, so it can handle a lot more weight. So now, what is this good for? Let's say you have a side of a building that the fire department requires access at all times. Well, fortunately, hopefully you don't have fires all the time, but you want to have the access. This is a great way to provide that access, permanent access that a fire truck can drive on it, but it doesn't generate runoff either. So it's, yes?
Is that like the turf they had at El Colegio? Does anybody know?
No, that was artificial. That
Well,
wasn't.
this is artificial too.
Oh, no, this is real, I'm sorry, this is real.
That's real.
But the soil is reinforced with the plastic mesh, so the soil doesn't get compressed. Compacted. Yes, sir.
So, in our last session, we had talked about soil types. Could that also be affected to the pervious pavement, like clay, silt, and sand?
A very good point. Exactly. So if I have a clay here and the water doesn't infiltrate in the ground, let's say I have maybe 3 inches, 4 inches of clay, I can just remove that, use engineered soils, put this material in it, put the mesh in it, so now I get spongier soil. So the water can either hold more water or allow more infiltration.
Or I can, create like a slow sand filter to have the water run off.
Absolutely. Water works best in that situation, and we'll talk about that. Yes, and then.
Oh, so what about like, next to around the lakes and next to the creek, using something like this instead of, asphalt?
Absolutely. Why not?
Well,
Yes.
So, okay, now what throws me is the clay is maybe naturally there, right? So we're talking about mimicking natural hydrology, but then we're taking out clay that was naturally there to put in this other kind of
plastic.
Correct.
Yeah.
Correct. Because we have to compensate for the impact we did.
Oh,
We created
sure.
the runoff. Now we have to get rid of it. You're
Oh,
absolutely
okay.
correct. It's just like taking aspirin, It's not natural, but it's going to solve the problem.
Okay,
It
and
does.
what,
It's
and what
just
do
a
we
tool.
do with that stuff when we redevelop that site and we no longer want to have a grassy parking area there? What happens with that plastic stuff?
That's a very good question.
Does it,
Is it recyclable?
is it recyclable? Is it
I'm not-
biodegradable? Do you want to pull it out?
Hopefully it's not biodegradable, otherwise it won't work. But
Yeah.
but it's a good point. These are just the tools.
Yeah.
These are I guess my analogy is just like the aspirin. It's a medicine, If we don't have any situation, we don't take medicine. But if you got to solve the problem, these are the tools.
But we also want to have some long-term thinking in here.
Absolutely.
I mean,
Absolutely.
And some of these are not long-term thinking. Some
Yeah.
of these are short-term thinking to conform to the existing policy.
yeah.
Yikes.
This is the area. This is just a quick example. I know we're short on time, but this example, this was a park site. I like this idea. I haven't, but I like the idea. They are using plastic, but still like the idea that it was a park, and because of the rules, they have to have parking. In order to have parking, of course, the normal approach would be asphalt or concrete. So they have to cut down trees because they have to get the right size, the right strength, and they have to bring asphalt impervious so water cannot penetrate, would generate runoff. The idea was, well, why not just the area that it was where they used to park, reinforce it, so then backfill it with gravel. Now they have this open gravel area, so the car can still park there to not generating any runoff. They didn't have to cut down any trees, they didn't have to do any updating engineering. They just transformed an area into a functional area, so it solved the problem. I thought that was pretty good deal. Rainwater harvesting. please go to our website. 3 classes that are coming up for free about rainwater harvesting. Maybe I should advertise about that. I'm sorry, thank you. I hadn't checked with you before, but it's a Med Council. Again, Minnesota, we're lucky. There's lots of information about how to do rainwater harvesting, and I can promise you for the next 10 years or so, this is going to be a hot topic because it just doesn't make sense to spend energy, draw water from groundwater, spend energy cleaning it, spend energy bringing it to our house, and we put it in our lawn, and we spend energy to cut down the grass, and so forth and so forth. We can save lots of energy by just using the water that we get right on site, at least for irrigation.
That one girl looks so little for that job.
Yeah.
That's what I was thinking too.
Fill up in 5 minutes.
I'm sorry, could you,
Actually, I stated that.
could you actually plug in when the class is? I'm sorry to interrupt right away.
No. I just,
Send me a note, I'll send it around.
yeah, it's in our website. If you go to our website, Stormwater University of Minnesota, you see it. Okay, another thing, so we end up with the water here. Now we cannot store it, we cannot do anything with it, but we gotta handle it. So we create these rain gardens, and I know down the road you will become expert in helping designing this and working on it. But for right now, we're just gonna cover the concepts. Rain gardens are areas that are gonna do multiple functions for us, right? Because we have 3 problems. We have a quantity problem, too much water moving too fast and causing quality issue. Well here, first of all, we can hold the water in here, right? And if we have a good soil, the water can go into the ground. If we don't have good soil, we can capture that water, put it in our storm sewer system. That's why it's either filtration or infiltration. If the pipe is not there, it has to infiltrate into the ground, becomes an infiltration basin. Otherwise, water simply goes through this media, goes through the pipe, and becomes a filtration. So that's the only big difference. But the water comes here, so we lose water through infiltration. The plants do a great job of allowing the water to evaporate through the plants, so we lose a lot of water through the evaporation. So we lose water on both ends. Very effective in capturing, holding, and slowing that water. So bioretention, that's why they're so popular. They're not the solution. They're not, no one PMP is the absolute solution. But they seem to work in many cases, so they're very good. One thing we gotta remember when we talk about bioretention, any question?
What is bioretention?
Any good question, I'm sorry. Let's call them rain gardens. Any area, remember, part of the natural drainage system was to have the low spots, the little spots where we can hold the water. By rain garden, all we're doing is creating those areas, the low spots where we can hold the water for a little bit so we can slow it down before it goes downstream. So we can either encourage it, infiltrate into the ground, or evaporate, or whatever is left will gently go downstream.
Okay.
Good? All right. One of the things is that we got to remember what comes in has got to go out somewhere. So however you design it, later on you're going to talk about this, you have to remember, we don't want to divert all of the water into a ring, this little old rain garden, right? You want to remember, just keep it in design. Whatever water comes in has to go somewhere. So there's this, what they call offline and online, and we'll skip the discussion on that one. For now. I just didn't realize. Okay, so this is just a picture of a rain garden. So when we talk about rain garden, we talk about an area, a low spot generally, because we want the gravity to do the work for the water to come into the low spot. We trap the water there. We have the proper soils or engineered soils where you can hold the water or infiltrate into the ground, and we allow the plants to do some of the work by the roots. Because what do the roots do? Every year, the roots, they're going to grow into the ground. They're going to die off. Next year, they're going to make additional network, additional root, and they're going to make the soils, transform the soils into sponges, right? A soil with lots of holes, lots of network, allow the water to infiltrate into the ground. And also the water evaporates through the plants. And this is actually was raining when I took this picture, and the water was coming into the rain garden. But they've done such a nice job with the soils that even with a half-inch rain, nothing was standing. All the water was infiltrating right into the ground. And this is another example here. They even used pervious paper next to the rain garden. So really, there was minimal runoff here. And again, and they're using the trees because we know the trees also, not only the leaves capture some of the rain, but again, a lot of water evaporates through the trees. So they also do a good job of minimizing and reducing the volume. Now you can have this bioretention or rain gardens in different shapes and forms. You can have the backyard version, but just in your backyard, they look very beautiful. There are many websites. Blue Thumb, folks are familiar with that one? Can't beat that site. I mean, it helps you to design it however you want. You can do this in a commercial site where you can capture all the water from a parking lot that comes in here. Then it goes into like a lip or a spreader where the water gently goes over that before it goes into a rain garden. What's really important, again, I'm just going to share some concepts with you for now, is that we have what we call pre-treatment. We capture that water that comes in with all the junks and everything. We want to capture that water, slow it down in one area, and then let that water go into a rain garden, because it's really important to have that pre-treatment, to capture all those junks, all the big chunks right away, so we can go back and easily take it out of the system with a shovel or something, rather than having to go and clean the whole rain garden. Now, another area of things that people have talked about, Minneapolis is the center of it. Actually, we have one of the headquarters this year is the green roof. The green roof, the idea was, well, again, we have this flat roof, the rain falls, rather than letting the water come down, why don't we capture right up there and then allow some of the water, again, evaporate through the plants. And we found that there's a lot more benefits with this also. It quiets the building, it helps with the heat and cooling of the system. So it's the building, so it's got multiple benefits, but also you can capture some of that water. Again, the idea is, remember that plot, we have this natural hydrograph and the sharp hydrograph. Every time we can hold that water on site, we're going to slow that, we're going to bring that graph down to the natural version. Green wall. When I took this picture first, I thought, wow, this is so cool. Just Google green wall. It's a matter of fact nowadays. Lots of buildings have green wall. Why not? You have this vertical structure, why not grow things on it? And why not, if the rain is coming sideways, why not capture some of that rain? Again, you're minimizing it. Yes, a lot of it has to do with aesthetic and looks, but it does some work as well.
What kind of planting is that? Because there are some kinds of things that are, degrade the concrete or the brick or the structure, and you don't want it because the suckers erode it.
That's good. I should have checked it. I don't know. I should have checked that. I don't know.
Yeah.
Anyone has?
Like, is it growing on a net or something, or what kind of plants are they?
That I'm not sure.
I've seen walls that have things like plants or baskets that you can build.
You can set up a separate trellising system in front of the wall and have plants growing in it, or actually have a separate green wall in front of the wall. Just depends on what the building structure is and what you're intending to plant.
That's true. So I should have had that check. Okay, what about the idea if there's no room, Hey, property is expensive. Again, this doesn't, I've only seen it a couple of times. In Edina, actually, I saw a homeowner who had to do this, which actually, we're going to store the water underground in this big pipes. I'm going to capture the water, so you can imagine a parking lot or a house or something on the structure on top of this. But I'm going to capture the water, bring the water, put it into these pipes, and let the water, again, gradually go into the ground. If the soils allow it, or maybe catch it into a storm sewer system later on. So this is another way of capturing that water.
I think we've seen some, for some of us that missed the actual first session, some of us actually went to, what was it, El Collage?
Yeah, they have a sequestration system.
Yeah, so isn't that like the same structure as that?
Same
idea.
Okay.
Yeah.
Good. So you guys are pros already. Okay, this was a quick review on the source control. Did it make sense? How are we doing? Are we doing okay? Mm-hmm. All right, we're grabbing the story. So I prevented. That was my first step. Always to start with prevention, right? If that part is skipped, it's not a management plan. Always we're going to start with pollution prevention. That's always the first order. Then we're going to control it on site. Whatever source control, whatever falls on the site, we're going to control it. Then what? I still generate runoff. It still has to leave my site. What do I do with it? Well, now I have to treat it. And when we talk about, when we talk about treatment, again, it has to minimize the runoff. It has to minimize the runoff. It has to improve the water quality. But one point I want to make, again, everything that we've talked about so far, anytime we reduce that runoff, we're really improving the water quality, right? Because we don't have to deal with it. So that's why it's so important to pollution prevention and source control, because the less we have to deal with, the easier it is to deal with. That's really the point of this collage. Okay, one of the things, one of the ways to treat water is to have a water quality pond. And I know as a homeowner, you would never go and construct a basin to treat water quality, but how many of you live in a subdivision that has a water quality pond in it, or know somebody?
You mean where it all runs off into it?
Yep.
Yeah.
So if you have bought a house that is less than 30 years old, that house, most likely the water from runoff from that house goes into a pond. So if you're in a subdivision less than 30 years old, then you have a water quality pond. So many homeowners deal with it on a daily basis. So that's why I just covered it basically. And the primary function of the stormwater is to capture the sediments. So the water comes with the sediment. Remember, we have lots of water moving, washing everything as the sediment. So all the water quality pond does, it captures the sediment and then it controls the flow. So the water comes, I'm going to hold it, something happens to it, which I call treatment. The sediments fall to the bottom, and I call that treatment, because once the sediment falls, I've gotten rid of some of the pollutants. And then I gently let that water go downstream.
And what do you do with the accumulated sediment over time?
Excellent, I have to maintain it, because if it's working, it has to capture the sediment, so every 15 years or so, I gotta go back and excavate the sediment. This is just a scary formula. All of this I'm saying, are you ready for this? Is the extent of my artistic expression, the PowerPoint. So this I'm going to show you why a water quality pond works. Because if you go and hold a cylinder of mucky water, what are you going to see? You're going to see heavy sediments on the bottom, a little lighter sediments in the middle, and the rest of the water is murky, right? Because it's suspended material. The reason you have that is because the heavy materials settle faster, right?
They drop quicker.
They drop quicker. So are you ready? Watch this. So we're going to capture the water. And for that, we have this very nice formula. Mr. Stoke in 1851 was able to quantify that. Was able to write a formula for that and say, you know what? And this becomes really important, because if your sediments are in this size, that means you're going to need a lot, because it took much longer for this to settle than this heavy one. So if you have a fine sediment, you need a lot of area and a lot of water, hold it for a long time. So as an engineer, you have to remember that. So somebody says, oh, you have the best water quality pond. Well, I don't know, do I? What's the size of the sediment, and how long is that water going to sit there? So those are the two questions you want to ask. So water quality ponds come in all shapes and forms. Some of them are terrible design, like this one that has a 2-to-1 slope here. Then you come up here, you have a wall, and then you come through here, and then you have a fence. If somebody falls here, it'll be a battle to get the person out of there. I mean, it's just, I don't know how you get. Some of them are actually very nice, and they're plants, and they look pleasant to look at. Yes, sir.
There was an article in the paper a couple of years ago about some municipalities were complaining about the real high cost of redredging these after they filled up.
Oh, they're torture. I haven't gotten it. Yeah, I wish we had time. Because there are rules. If you go pick up the sediment, do I have a picture? This is a nicer one. Well, very quickly. Because you're absolutely right. If they work, what should we expect to know? If they work, we gotta have sediment. If it's not work, if you go to a pond and somebody says, "Oh, it's so nice, it's clean," what does that tell you? I've wasted my tax dollars. It doesn't work. It wasn't needed, because if it's working, I gotta have mud in it. What do I do with that mud? Every 10, 15 years, I gotta go back in it. Actually, I have a picture. We'll talk about that picture too. So I gotta go measure how much sediment I have. If it's more than half full, then it's time to get it out. I go out there, I test it. If it's 97% or so sand, then I know, oh, okay, it's mostly sand. Inert material is not gonna cause problem. But if I take a sample and say, you know, half of it is organic, it's mucky, that means it's got a lot of pollutant, then I better do some tests to make sure I don't have heavy metals in it and so forth. And then I need to dispose of it properly. And right there, you're talking about hundreds and thousands of dollars per acre feet to get rid of it. So the cost, when I did the first pond, I think the cost was like $7,000 to clean a pond. They call it cleaning, to go in there, remove the sediment, dispose of it. Right now, it's not unheard of if you're talking about $300,000 for a pond to maintain it, to clean it, or to get the sediments out. So you're absolutely correct.
Where do the sediments go?
The sediment, if you test it, if it's 97% sand, so it's inert, you know, there's not much material in it, and it's just sand. You can dispose of it on a farmland or some areas, you know, just or a regular landfill. If it does test for materials above a certain threshold, then you need to dispose of it properly in a landfill that can accept it, and landfills then it's constructed properly to handle these materials.
So it's hazardous waste.
It's, yeah, I didn't want to say that. I used to work for a city. You hear that word and you're stuck with that, you know, forever. So some places, what they do, they just, you know what, dig another one, let that be there. It's cheaper to dig another one. Okay, we got to go. So, but now we're learning to make them look much nicer. This is a library in Plymouth, Hennepin County Library. It's very nice. So we have, you know, native plants and everything is on the pond. Again, it's not something a homeowner would do, but you deal with it on a regular basis. So I just thought to talk about it. And they come in many sizes. You can have multiple ponds, regional ponds, and so forth. But the whole idea, again, is they do to trap the water. Remember those things falling? You trap, you allow for the sediments to fall, and then you let the water go out gently. That's all this water quality control is. Yes?
So these ponds are permeable in the bottom, right? They
Yes.
Go down. It's just that it's sitting there until it manages to drain.
But they're designed to always have what they call a permanent pool. They're designed to always have water in it. So if you test the soils and the soils are sandy, allow the water in, then you line it with the clay so the water doesn't infiltrate into the ground. So you can hold some water because that's how they can trap the sediment and be functional. They gotta have some water in it. Did I answer your question?
But some of it will go down.
Yes.
I mean, that much though?
Yes, on the edges and so forth.
Oh,
yes.
okay, but not much. Okay.
I mean, they're designed not to allow it. They're for the permanent pool on it. And if you go to our website, there are 2 classes on water quality ponds, so you can look at the things. All right, so we go back to BMPs. Again, just personal opinion. Number 1, BMP, best management practices, preserve natural areas. Sometimes, again, we get so sophisticated, we like high-tech, we like really complicated solutions. You know what? I think it was you who talked about this plastic in the soils. It does magic if you don't disturb what's there to begin with. Then you don't have to put anything else in it. We didn't have that approach. Years ago, we used to go for development, got rid of everything. Then we put little, I don't know, trees, whatever you want to call them, in front of each mailbox, and that was it. Now we're learning, we don't necessarily have to get rid of, if there's a water waste, we don't necessarily have to get rid of it. It actually increases the price of the house. If we have trees, we do not want to get rid of it because the trees are really important. So we're learning all these things, and now they're coming back as part of the green infrastructure. So keep things that's there. What do they do? Don't mean to bore you with it, but it's really important as a designer, as an advocate, when you talk about development, to remind them that we're by preserving natural areas, we're reducing impervious area cover. We're reducing hard cover. We're not creating it to begin with. Preserve natural lands, it leaves the open space. Again, you don't have to create it. It's double goody, First of all, you don't create the problem and you don't have to deal with it. And we can use the pervious area for more than one purpose. Maybe we can even put some of the runoff back into it as a way of recharging the groundwater. There are ways you can, so there are many ways to do this. The key elements, again, you can tell I'm a little biased about this practice. So the goal is to, it's because the important thing is every time you preserve the natural area, you're not creating the problem. You don't have to deal with it. That's the important, just the pure math. Again, the goal is to reduce runoff. It's a multifunctional landscape. We can water, and we can treat water as a resource. We have a creek. We don't have to put it in the pipe. We can use it as an advantage for development and so forth. But maybe quickly, one of the main things I think we're learning is that we fit development into the landscape. I was going to share with you an example of a high school. This is years ago. This is a large high school in the city of Plymouth. The idea was we had a high school for 3,000-4,000 students. Obviously, we had a large area. How do we build the high school? Well, first of all, you can see the high school, the structure is not straight. They bend it according to the creek. Yeah, maybe they shouldn't be there, but now that they're there, at least they redesigned the building so it follows the creek. So that was one of the first things to do. But the idea was, how can I do this if I'm going to follow natural hydrology? So what they did, they went back to the old aerial photos. They looked at the natural hydrology, how the water flows. This is the creek. You can see the trees around it. This is the aerial photo from, I forgot what year it is, 1956. So when they constructed them, when they were designing it, they followed the same general pattern of hydrology, the general flow. The water flows the same way. They didn't change the hydrograph that much. A couple of things. I know I'm running through these examples. I'm sorry. I wish we had more time. But a couple of quick examples. What is one of the things you see in this development? The parking. These are the buildings. One of the things that I noticed is all this. If you can see it, all these green areas. It's not all concrete. Lots of open green areas. Again, yes, they have to regrade that area, but it's open. If the water finds its way there, it can infiltrate into the ground. And you can see they use a lot of ponds. All the trees are left. So at the end, this is what was there, and this is what's there today. Not much difference. It's fit into the general idea. And that's really the idea. When we talk about green infrastructure, this is all the things we're talking about. Something that fits into the general area. So, we design like nature. We've gone over this a number of times. We talked about it for landscapes and for the counterparts. Whatever we have in the natural area, natural drainage, we want to do the same thing in the constructed. And there are whole sets of best management practices that do that. And all you got to do is go to EPA's Green Infrastructure site and you can see lots of tools, lots of information. So, we're almost getting, the good news is we're almost getting there. So, we have what? We talked to you about the problems, and for the past few minutes we've also talked about what? Solutions. We have solutions. So that's the important thing. If we go into development, we don't have to get that bent out of shape. We have solutions. The idea that we're not suffering because of lack of solutions, we just need to implement them. We have lots of solutions. That's important. I think I'm running out of short, but is it okay? Should I skip this? I have just like 10 slides. Should I skip them or just run through them quickly? Okay, this is just, okay, you all yell at me, you all yell, what are you looking at? What is this example of?
Desolation.
What is it?
Desolation.
Oh my God, rain garden!
There's no life in there though.
It's a brand new rain garden.
You actually corrected
They
this.
look like they weren't lively, so that's
a good
the
point. It's a good point. What are we looking at here? The water comes down here.
Swale.
No, it's a point. It's just slowing down the water. Again, there's a way to slow down the water. What are we looking at here? The water moves that way. And these are check dams, trees for check dams. What does it do?
Slows it down.
You got to do one of the three things, right? If it's not doing that, it's not a solution. It's slowing down the water. And every time it slows down the water also infiltrates in here. So it does two of those problems. Very good. What is this gentleman doing? You know what? Hydro seeding. We impacted the area. We know it's going to rain. We've got to cover that soil. We can't let it sit bare. We're going to use hydroseed. It works beautifully. We can mix compost in it if you want to. Sometimes it's not a good idea, sometimes it's magic. Depending on whatever situation is, we hydroseed it. Problem done.
Are there native seed mixes for hydroseeding in Minnesota?
Absolutely. Years ago it wasn't. Today you can design it however you want. It's to a degree. I mean, you can, you know, it's a lot of vendors are out there who are doing a lot of great things. These two gentlemen, both PhDs, by the way. What are they doing? We talked about ponds. We want to know how much muck we got in the pond. So they're out there.
Taking a sample.
They're sampling it to see what it is, how much pond muck we have there. What do we have here? Homeowners here, open fields here, school was here. When you see the school. Absolutely. They said, we have this open field, too large for the two soccer teams. We can use some of the area to have a wetland to treat all that's runoff. They create a wetland, all the water sits there, and after the rain, this fills up. That water going, washing all the fertilizer and everything downstream, goes into the wetland before it goes into a lake. We have a park. They had a parking lot. This is the church. They had a huge parking lot. They said, you know, it doesn't get used that often. Why create the runoff? What do they do?
Rain garden.
Cut it out. They put a rain garden in the middle, and on each end they put pre-treatment area to slow down water so it doesn't wash the rain garden. Here, there's another fancy one. It's the same idea. I have all this parking lot. It only gets used twice a week. Why do we need that much room? Let's minimize the water. The homeowner here, it looks like, how does this look? Exactly what it is. This area was supposed to be darker. They capture all the water, actually all the gutters, they got it here, and the gutter dump the water here, it goes into this gravel. You know, they didn't want to deal with bushes, flowers, but it still does the job. It's wonderful. All the water goes, but you want to make sure it doesn't get back into the basement, right? So you want to consider something.
That's good, that's good.
Yeah. This is, what do we see here?
Oh,
by the way, it hasn't rained for the past 7 days.
And it's just sat there?
Good observing. We have a problem here. This is a rain garden. The water is supposed to do what? Infiltrate. It's been 7 days. It's not working.
And you even got that little drainage system right at the top too.
Yeah, we see a problem. This is where the water comes into this is the water outfall. The water comes into the. There is no pre-treatment. The water just comes with all the sand and everything right into the rain garden. So it's not working. So that's what we want to have pre-treatment area where we can capture that water from the street and grab all the big rough sediments before it goes into the rain garden. Then the rain garden can be beautiful like this, and we have all these materials. And I'm sorry that I ran through it. But the good news again is that we have solutions. All right. So, takeaways. Why do we care? Because we want clean water, right? And the things we do does impact clean water. What's the problem? I know you're sick and tired of me asking that, but it's got to be second nature. What's the problem? Right, we get too much water moving too fast and degrades the quality. And if your solution doesn't solve one of those three, it's not a solution. You know, it's not, you're not against anything, but it's got to do one of those three things. Anytime somebody proposes, does it do one of those three things? If it does, good, else get it out. To solve the problem, we have to be mindful of two things, right? We have to design it for a future climate, and we also have to ask, where does that water come from? Where does it go to? And, okay, good? All right, so let's do another exercise. Get some energy back here. Okay, it said 15 minutes, and how about it take 3 minutes? You guys work. Okay, so what I'd like to do, maybe work in groups of 3s or so, and come up with the 3 types of BMPs. Remember, pollution prevention, source control, or site control, and treatment. As many as you like. And talk about it among yourselves. What's their function? What do they do? Which one of those main 3 problems they resolve? And just some pros and cons. Is that clear? Does that sound good? Are you okay working with your own team already?
Yeah.
All right, good, because I cannot do any mediation. Take your time, so I'm in good standards with Peggy to finish off the material. Maybe 1 or 2 volunteers to tell us what, let's say, what were the 3 type of stormwater BMPs that you came up with? I know that team back there volunteered to come up with the first answer.
Rain gardens.
Exactly, and rain gardens would be what type of a storm? Would that be a pollution prevention, structural, non-structural? What would you say that would be? On-site control, site control, whatever that's called.
All of the
Source
above.
control.
All of the
Actually, it is all of the above.
Yeah.
Okay, good. Any other kind of BMPs?
This is kind of related, but there was the one where you were talking about salt and not using it, that housekeeping thing. And one of the things is that, you know, in cooking, you have substitutes. So instead of butter, you want to use something else that tells you what to substitute. It seems like there ought to be some kind of chart, which is our project, by the way, no idea, where you can say, instead of salt, use this.
Absolutely.
And then the use this column is often more expensive. So then maybe there ought to be how to make it yourself.
Very good,
So
yeah.
what can you use that's inexpensive, like, you know, like making your own detergent, but that kind of a thing. So that people could see
Absolutely.
what the different options are. And you probably have to describe how it works. So how does chicken grit keep your sidewalk from being slippery, and how does it save your concrete? So putting those pieces together, so
Very
people
good.
would understand why they should do that.
Have a table of solutions, a different type of solution. Excellent. Good. Any ideas from this part? You were supposed to help out.
Oh, we help out all the time. Okay, fine, we did con, and the bad, it slowed down the rate and improved the quality and reduced the quantity. Bad thing is when they come back in 20 years and say, by the way, we're gonna assess you.
Yes, yes. And I'm sorry if I misspoke. You said a good point. You said it does 3 things. Water quality points, it reduces, it cleans the water, so it treats water quality. It slows down the water. It does the rate, so it does the 2 things. And if I said it reduces volume, I shouldn't have said that. It doesn't reduce volume, right? Because we have the same amount of water that comes, we hold it, and we let it go out. We have the same amount of water we start with. We just slow it down and we treated it. That's why it was way at the bottom. That's why. Very good point. That's why it was way in the bottom, because our focus is to prevent it, treat it on site, and capture it on site, and if we cannot, then finally treat it before it goes downstream. Good point. All right, thank you very much. Oh, you guys are a good group. Okay, another good news is that we're done with 3 chapters, we're only 4, we're only left with the last one. And the last chapter is, here we talked about the plan. What we talked about the solutions, how do we implement the plans? So it's like 2 parts into this chapter, the plan and our home site, and we'll talk about both. And the point we want to get in our plan is that there are no silver bullets. Okay, that's really important. There's always a series of solutions. Yes, there might be some occasion you could use one. But in reality, it's always a series of solutions. There's no one solution. That is your management plan. When you want to work with the developers, when you want to work with the city, you got to remember, there is not one thing. And I love this thing that says, if all you have is a hammer, everything looks like a nail. If then so many times we go to the different sites and we see people have used the same BMP over and over and over. They use a BMP that's made to reduce the volume, but water quality ponds, they use maybe 4 water quality ponds. Did we reduce the volume? We did. We have a super clean water, but we still got the same amount of water. Or maybe they do maybe all they have is pollution prevention, but we know in reality we're never going to go back to 0. We have some runoff, we got to treat it, and we need a water quality pond. So it's always a series of BMPs. And that's only one slide on that one. But but my point is, it's that important. It is important. There's always more than one BMP. There's not much else you can say about it. It's always serious. Okay, quick review. Now you know exactly what does this represent?
Normal, natural.
Natural. What does this represent?
Relative.
Yep, impact in the landscape. And this is the glob of water that causes the problem. That's our excessive runoff, the extra runoff. and it creates the 3 problem. I won't ask you again because you know it already. It's too much water moving too fast and degrading water quality. What was this called?
Management train.
Treatment train. We want to go through this series of PMPs, right? We want to go through a series of PMPs to get the job done. And our solutions, our driver is to mimic natural hydrology. And we know to mimic natural hydrology, we've got to design with the season in mind, climate in mind, and we've got to have a watershed approach. And the question we said to ask as a watershed approach is that where does the water come from that comes on my site, and where does it go after it leaves my site? But the question becomes, well, what is a watershed? You know, we talk about watershed approach, watershed this. I'm sure you all talked about it last time as well. So we can go through this super quickly, right? Okay. But what was interesting, the reason I thought we would talk about a watershed, if you don't mind, a few minutes, because we're sitting in a kind of interesting spot. And I looked and said, oh, I think this is where it is. Oh, I checked it, and it's kind of interesting, so I'll go. So a watershed is what? Since you guys talked about it last time.
Land area that drains into a water body.
Excellent. So on the large scale, we're looking at Minnesota, we have maybe 8, 9 major watersheds, like the major rivers, like the Minnesota, or Mississippi, Minnesota, and then we go Red River here. They all go into one spot. So if you look at it here, this is Mississippi River, and each one of these main watersheds, they got subdivision, the area that goes into Little Creek, and our area, of course, is Twin Cities right here. And I said, oh, so this is our area. We're sitting almost at the end of this part of the Mississippi before it goes into lower Mississippi. I said, oh, interesting. So we're sitting kind of at the end of the funnel. So I said, okay, so if I look at that area, what do I see? And I said, well, tonight we are somewhere around here, I think. I said, oh, I wonder what part of the watershed that is. So if this is the Twin Cities part of the, so here we're looking at this large watershed, Mississippi watershed, and this is the Twin Cities part of it. And we're sitting right somewhere around here, and actually we end up to be part of the Minnehaha Creek Watershed District. I thought, oh, okay, that's interesting. We're kind of end of another mini watershed. So it's, again, another end of the funnel. So I just bring that up a little bit, expanded. And this is the Minnehaha. So this is Lake Minnetonka, and Minnehaha Creek comes all the way here, and we're somewhere around here. So this is, again, we're really at the end of the funnel. This is kind of fun. Drilling down. And what was really fun when I looked up the aerial photo, and this is where we are. Of course, this is an older thing. Things are a little different now. Actually, you're sitting right on a divide. All the water on that side of the street goes that way, and everything here goes into, what kind of lake is this? What lake is it?
Nokomis.
Nokomis Lake. It's Nokomis Lake. So interesting. Oh, so we're really sitting right on the edge. And when you look at the whole picture, and the idea was, you know, this runoff is a watershed scale. It's a large area we're dealing with. But also, it's a problem that we handle on site. It's something that we have control at every point. And this is a good example. Here we are at the very bottom of it, where we're receiving all this water, but still we're contributing. So stormwater runoff is a watershed scale problem. That's important to understand. It is a watershed scale problem. But we can manage it at a small scale. Okay? And that's the trick. It is a large, but it's managed at every point, and as our home site. So that's how you get to find out how we can change this and how we can make a difference. Well, I thought, well, how can we go about this? So let's, again, this is us sitting here tonight. And let's ask the question, well, how can I manage the water here? You know, if you were, let's say if you were going to develop this area, or right now if we were going to go outside, how would I go about improving the surface water management or the runoff management? How would I do it? Because that's the end results, right? You want to be able to go out there and say, you know, I want it this way. This is how you want to build that village or subdivision, make $1 billion, and improve the environment at the same time. Nothing wrong with that, right? But how do we do? That's what we're going to be able to do. So it's okay. So if we go here, what can we do? So I looked at this aerial photo, and this is a disclaimer, because my goal was, I didn't know about the construction, so I had to change plans. So everything is different. So, so this is a disclaimer here. This is made up. So, so these points here are the elevation in meters or feet. This is feet. The elevation, like how high or low the ground is. Is that clear? So this point here says 826. That means it's 826 relative to the sea level. Here is 820. So which one is lower? 820. So it's a lower. So the water, if I'm standing here, the water comes which way? This way. And then in the middle of the water, it says 822. So is the water going to go here? No. So both this water and this water is going to come down here. So this helps me to realize how the water flows. Why do I want to know this if I'm developing? Because mimic, what am I supposed to do? Mimic the hydrology. First of all, I got to figure out what the hydrology is, right? And then I want to mimic it, then I want to capture the water. Yes?
So are there maps, like you could look anywhere in the city and find out the elevation and all that?
We're very lucky in Minnesota. Almost yes. We're very lucky. Actually, a lot of cities use a program called Geographical Information System. Anyone familiar with this?
Yes.
I'm sorry,
ArcGIS?
ArcGIS, somebody said the magic word. It is amazing. You can go in there, actually, if you go to USGS, look at topographic maps, USGS topographic maps, you can transpose it on Google Earth, and anywhere in the US.
You'll be doing this in the rainscaping utensils.
Oh, yes.
We'll be actually doing this activity.
Okay.
Thank you. So you get this, it's fun. So let me, so what am I leading into is,
ArcGIS is a tool.
actually there's an online version too.
Yeah.
The technology is wonderful. So what we're going to do tonight we want to do a quick exercise of how we can do some quick, and again, this is the concept of it, because Peggy mentioned later on you're going to design these and you're going to actually do them and work with people who construct them and everything. But this is just a warm-up, just get an idea how we can do that. So we looked at this and said, okay, so this is the high area, this is where the water would go. What does that say? Lowest area there, so that might already give you some idea of what could happen there. This line in the building, usually when you build the building, when you construct a building, usually half of it goes one direction, half of it goes another direction. And same is true for fields. Usually half of it goes one direction, half of it goes another direction. So this says 832, this is 846, sort of gives you an idea. All right, so it's something that actually happens every single time. Every time you're developing, engineers and designers and landscape designers get together and they divide up the whole thing before they design it. They say, where's a good place for rain garden? Where's a good place for the pond? Where's a good place? They look at all the topography and look at the elevations. They look at the area. They should look at the natural hydrology, so everything just pretty much stays the same or improves maybe. If they're doing redevelopment, they can improve it. So, are you up to give this a shot? Mm-hmm. All right. So what I hope I've made enough of this. So this is the same thing for your team. If you can get in your team, and based on what we've talked about. Yeah.
Oh yeah.
I'm not too worried.
Thank you.
Oh.
All right. I think we have plans. We have more here if you like it. So what I thought we do, getting your own team used to work, and I thought maybe we could do a couple of things. Again, this is just a practice as a concept, right? We're just a warm up. So when you're dealing, I think Rusty Schmidt is going to be the teacher for the. And I got to tell you about Rusty. He's a nationally known gentleman. He's fantastic.
The blue thumb guy, Rusty wrote that. Oh, so he'll be your instructor.
Yeah, he's very, very nice guy. And very good at what he does. But tonight we thought maybe we can do 4 things if we have the time. We'll take some time to do that. Looking at that, what we call aerial photo. It's just a photo, taken from the bottom. And look at this limited information I've given you with the spot elevations and those few lines here and there. Let's see if you can figure out, because we want to think watershed. So the question we have to ask is what? Where does that water come from? Where does it go to? Let's say we can do that. If we can we answer that question? And don't forget the rain, right? The whole area captures the rain itself, so that counts too. How does the water leave the site? What's the exit point? Where does it go to? And don't worry if it's not exactly what's out there. What do you think? And let's get a little gutsy. Let's see if we can guesstimate how much water we're dealing with. There is a measurement on it. I tried to give measurements. It may not come out. This line on top is supposed to be 1,150 feet long. Okay. And the building is 165 feet wide. If you can figure it out, fine. If you don't even worry about it. Because later on we'll get it. But if you get it, and then, or you can just come up with magical numbers. Magical. I don't know. It's okay for you. But at the end of your team, this is the important. Which one of the solutions would you use and where on that site to deal with that excessive runoff? Is that clear?
Yep.
You excited to do this?
Yeah.
All right. Okay, let's say really like 10 minutes to do
30
this.
seconds.
30 seconds.
Rain.
But maybe you can take just maybe a couple of minutes to go. And again, I apologize for interrupting you because what the good part is you're going to have a real professional help you do this later on. And Rusty is amazing at doing this. And you'll go through the same exercise and actually, with the help of other people, will construct the BMPs. So you got a lot of exciting things coming down. So, but maybe a couple of volunteers to share with us some of the things you have found. Who would like to go? What team would like to go first? Okay, I'm getting bored.
Do we answer in any specific order?
Absolutely.
Our estimate of, I guess, we tried to answer number 3, and as far as cubic feet, we came up with 1,000. We came up with 1,102. Wait, yeah, is that right? 1,208.33 cubic feet.
Wow. Anybody else confirm that?
Just an average.
Oh, my goodness.
110,000.
Excuse me.
110,000.
110,000, right?
208.
That's a good amount of water you're dealing with.
What's that?
We had 4,700 for hardscape, and so equating to 35,066 gallons.
Excellent. Did you say hardscape?
Yeah.
You mean the impervious area?
Yeah.
So what was your logic on that? What were you thinking? Excellent. That's a very good number. When you got two people coming with the same number, that's excellent. So you were looking at the area that's impervious versus the area that's pervious. So maybe you could, so this is a good thing. So first you start saying, okay, what's the total bulk? Gives you a great estimate, I want to know, I want to know generally how much water I have to deal with. Then you're going to go, next step is to look at and say, well, remember that plot we looked at? That we had this hydrograph, we had the natural hydrograph and an impacted hydrograph. Actually, you have a mini version of it happening right here. On the side where you have the buildings, where the water is going to hit, it's not going to be able to infiltrate into the ground. It's going to run off instantly. So you're going to get a sharper one. Here, hopefully, the turf, it's not totally compacted. Some water may infiltrate into the ground. Hopefully, it's not the case. And maybe the water, some of it gets infiltrated into the ground. So you don't get the same amount of runoff generated from both sides. So excellent. So good job. Thank you. All right. What else? Come on, you guys.
Well,
I know it's
well, as far as identifying the source, we're just thinking it would all come from rain on the site, and it didn't, we didn't think anything would come from off-site because of the streets and the curbs and everything.
And that is really important. Why? Because depending on how much water you're receiving, it's going to dictate how much BMP you got to put in place. And are you responsible for that runoff? Are you responsible for somebody else's runoff that comes in your site? Do you have to deal with it? I mean, so it's really important. The first question I ask, well, what am I dealing with? That's very good. Okay, maybe a couple more?
Well, there's a lot of impervious surfaces here, the roofs and the parking lots. So a lot of the water is running off of those. So that would be a source.
I'm sorry, that was would be what?
That's the source.
That's the source, absolutely. The roof itself is the source of the runoff. Well, okay, what about down here? How would you deal with this problem?
We put a green roof on top of this.
All right. Why a green roof? Excellent. So we got a green roof, and you thought about the plants. You wanted certain plants that you know it's going to stay around here, or maybe you designed the green roof in a module format. So if it gets really hot, really cold, depending on 5 years from now, you can just take those modules.
Up there and take it down?
Who caused more problems today? Go up there. Okay, so that's true. Okay, what are the BMPs? Because we want to use a number of BMPs. Yes.
With all the water collecting down on the lower right-hand side of the lot, then it makes sense to use that really low spot to create a stormwater pond, or just a really big new wetland or rain garden or.
Exactly. How many other people thought about putting something in that area? All right. Good.
Also right in the middle, very middle of it, where it's 820.
Why not?
A garden or something of that sort.
Part of the discussion back there was we were talking about on the field, or maybe the team in the middle, why not use one of those reinforced lawns with those mesh into the soils where the grass can take in more water, so it can infiltrate a lot more. So when it's raining, yes, you're going to get a little more water build up there, but if they're not playing, it's not a big deal. It goes into the ground, you minimize some of the runoff, and you use the open space, multiple function area, because that's the trick. We don't have as much space, so we want to have multiple layers of different use on the same spot. Okay, did we miss anything? Was there something that you were really hoping and wasn't covered?
Well, we could put rain barrels in along some of the buildings.
Absolutely. Why not?
Does core aeration do anything to help with infiltration? Not really.
Well, it would, I guess I was thinking in the long term, if it does help the grass roots, if it really helps the roots to grow, because every year, a third of that root is dead, and it regrows. A new root system grows. So, if that helps the grass to be healthier, deeper root, then it's going to have a spongier soils, more infiltration.
And no solution is going to be install and you're done. Every solution is going to have some kind of maintenance plan with it.
Absolutely.
And that could very well be part of the maintenance plan.
Help with compaction.
Yeah, every 5 years you need to do this or that.
Part of the challenge with lawns is the root systems are in the top couple of inches and it's very dense and matted. Whereas with native plants, the root systems sometimes will go as far as 2 to 7 feet into the ground. And that's where you get the real penetration of the water.
Good. So you were able to do a stormwater management plan, right? And you did it right at where it counts. All that water goes, exactly goes left in the comments, and that's really exactly how it's done. So with that, I think we're ready to wrap it up. We're done pretty much. This is quickly what we talked about. I'm sorry we didn't have more time on the discussion. If there are no questions, thank you very much, and I'll let Peggy take over from here. Thank you.
All right, so I confess, I'm a total geek. I'm sitting over here in the corner going, this is cool. This is really interesting. I have one plea to make before you leave. This is a work in progress, and you are helping us make progress. So one of the things on the website is under for Stewards is course evaluations. I'd like you to look back at the watershed tour and look back at the basic hydrology course and evaluate those courses so that we can continue to refine these basic feedback. Really important. Be honest, be really generous with your feedback, give us lots of comments when we ask for them, but really help us think about these courses and how to make them work the best they can for you. Question?
I missed basic hydrology. Can I find it on the website and walk myself through it?
The PowerPoint?
whatever.
Yes.
Yeah, all
Okay.
the materials are.
We're
Okay.
putting the materials up on the website, so we'll have the watershed tour video soon. We have the narrative up there now. We have the basic hydrology PowerPoint.
Okay.
And we'll have Shane's PowerPoint up there as soon as we get it.
Is there, did you do any recording?
Yes, that whole,
So there's narration that,
the entire thing was videotaped, so we will put that, is that video up?
The video is of the hydrology part.
Yeah,
So,
but-
so
Great, okay,
PowerPoint
thank
and the
you. Okay.
video of the entire class
great, thank you.
is up. If you've missed a class and you're trying to make it up, it might be really good to contact somebody and ask questions, collaborate with them, get their notes, share notes with other people. So use your fellow stewards as a resource as well to catch up on things that you missed. Any other questions?
Well, you want to keep on
The questions you guys are asking were critical thinking too. It's just fabulous. It's so impressive. Thank you. Good night.
Thank you.
Yeah.